So, okay, good evening, students. So, in last class, we discussed regarding mainly the concept associated with static indeterminacy and determinacy and kinematic indeterminacy. But in this class also, we will focus on some basic things related to structural analysis. That is, in this class, we will try to make some numericals on what is meant by static indeterminacy, how to determine static indeterminacy, and also what is meant by kinematic indeterminacy, and also how to do kinematic indeterminacy and all. Afterwards, we move on to slope deflection method as well as moment distribution method. Because when we are doing slope deflection or moment distribution method, The kinematic indeterminacy plays a major role. So depending on kinematic indeterminacy chosen, we are determining the moments, final moments. That's why whether it is a static indeterminacy or kinematic indeterminacy, they may appear in your MCQ questions, because if they are putting analysis of SD and MD method, you may get questions on static as well as kinematic indeterminacy. Okay, so let me start with what is mean by structure, and also what is mean by different types of static and kinematic indeterminates and all. So well, before studying this, so we will just try to make what we studied in last class. So we know that any structure, any structure, it is subjected to load. Any structure is subjected to load. What happens? We can expect deformations, deformation. Because what are the things responsible for deformation? Forces. There may be a internal forces or external forces. External forces. Therefore, static indeterminacy and kinematic indeterminacy plays a major role. What is meant by static indeterminacy? First thing, what is meant by statics? What is meant by statics?
Non-moving, stationary.
Non-moving or stationary, right?
Yes, sir.
Static indeterminacy. So the word static means stationary, which means at rest. It's not moving. What is meant by indeterminacy? This is unknowns which cannot be analyzed with the help of equations of statics. So which means that, so you are getting some unknowns, then the indeterminacy can occur. See what happens if you see the fixed end beam or proper cantilever beam. Here how many reactions will develop at fixed end? 3. At free end we are having one prop, so 1. What is the total reaction? 4. Now what is the available equation?
3.
Available equations are 3. Therefore, if you take indeterminacy, so available equations are 3. So 4 minus 3, it will become 1. So this is indeterminate of order 1. Indeterminate of order 1. So we can say that it is indeterminate by looking up the beam, by determining the external reactions, and as well as available equations. What are available equations? We know that the available equations are
3.
Sigma fx equals 0, sigma fy equals 0, and sigma m equals 0, right? But strictly speaking, when they are asking questions, this is the direct way of doing problem. Direct way of doing problem is identifying the indeterminacy is very, very simple. How? We just identifying the reactions first. Here hinge, 2, here this is roller, 1, once again here fixed 3. So total 2 plus 1 plus 3. What is the total reactions? 6. What is the available equations?
3.
Available equations are 3. So what is the indeterminacy?
3.
Indeterminacy is r minus available equation. So r minus 3, which is 3. So I can say that it is indeterminate of order 3. But strictly speaking, this is one way of computing indeterminacy. But we are having some equations, some analytical equations to find indeterminacy. Okay, so in this particular section, we are going to study what are those empirical equations. Okay. Now, so we know that for truss, yesterday we just gone through the things. What is the total? So generally the thing is the total indeterminacy. First we are doing static indeterminacy. In static indeterminacy, static indeterminacy, let's see. First for trusses, what is the equation? For trusses, total indeterminacy is given by m plus r minus 2j, where m is number of members, where r is number of
reactions,
external reactions, external support reactions, where j is number of joints. J is number of joints, where j is number of joints, where j is number of joints. Okay, you have to remember. So how we arrived this? For truss, m is the number of members available. 1m for truss, we know that for truss yesterday we discussed 1m. For beams 2m. For rigid plane frames, how much?
3m.
Please remember this. For truss 1m, for beams 2m, for rigid plane frames 2m. And also this is static equations. So number of static equations or number of equilibrium equations. Number of equilibrium equation for truss, how much? For truss, which is 2. For beams also 2. What are those for truss? Sigma
Fx
equals 0, sigma Fy equals 0. For beam, sigma Fy equals 0 and sigma m equals 0, not sigma Fx. Have you seen the beam? Generally, we are not having the inclined force. Generally, we are getting only shear, perpendicular force as well as moment, right? For frames, for plane frames, how much? 3. What are those? Sigma Fx equals 0, Fy equals 0 and sigma m equals 0. See, MCQ what are the equations of equilibrium available in truss? In beams, in frames. You generally beam quotation 3 inta madbidtira. Sigma Fx equals 0, sigma Fy equals 0 and sigma Fx equals 0 anta. Idu Fx aru irutte illa Fy aru irutte. Eradu saha iralla, one moment irutte beam alli. So it's a type of axially rigid nimgirodu. So that's why any one force irtade. So for truss, that is 2, sigma Fx equals 0, sigma Fy equals 0. It's an axially rigid. There is no moment in truss. We know that. For frames, for plane frames, we are having 3. So now, with the help of these two things, we have arriving the equation for truss. I equal m plus r, one member, 1m plus 1r minus 2j. Similarly, for beams, what is the equation for beams? I equal how many m's? 2m plus r minus 2j. For plane frames, how much for plane frames?
3m plus r
I
minus
equals
3j.
3m plus r minus 3j. 2j, 3j. See, 2j, 3j. See, you can expect a question directly in your MCQ question. Directly. So this is also very, very important. Please make a note. For trusses, m plus r minus 2j. For beams, 2m plus r minus 2j. For frames, 3m plus r minus 3j. Where I equal what? Where I equal what?
Statically indeterminate.
Total static indeterminacy. Where I is total static indeterminacy. And M is number of members. M is number of members. R is number of external support reactions. J is number of joints. So what is total indeterminacy? Total indeterminacy equal, see, I equals external indeterminacy it's called E plus internal indeterminacy. That is small I. Okay. So total indeterminacy I equals E plus small I. Total indeterminacy of the structure, which is the sum of external indeterminacy plus internal indeterminacy. Any doubts? Clear? So this is total indeterminacy. We are having equations. Okay, now how to compute external indeterminacy and how to compute internal indeterminacy. That is very, very important. That is very, very important. Okay. For external indeterminacy, E equals total number of reactions. We know that. What is the equations of equilibrium? That is C 2. R minus 2. This is for beams and
Truss.
truss. You have to remember this. This is a very, very important topic. It's a very, very important topic. And E equals R minus 3 for what?
Rigid
Yes, rigid plane frame.
frames.
Yes. Rigid plane frame. See, please take a note. This is also sometimes idanne haakbidtane direct agi. Ee question ne haaktan direct agi. What is the external indeterminacy for beams? R minus 2. What 2 indicates? What 2 indicates and what 3 indicates? You know.
Equilibrium equations.
Yes, equilibrium equation. See here. See, in one slide I have explained what is mean. Now if this R is known alva, ಈಗ ನಿಮಗೆ R ಗೊತ್ತು ಅಲ್ವಾ? So ನಿಮಗೆ external ಗೊತ್ತಾಗ್ಬಿಡುತ್ತೆ. ನಾವು internal indeterminacy ಹೆಂಗ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀರಾ? How to determine internal indeterminacy?
Capital I static indeterminacy minus external indeterminacy.
Yes. Internal indeterminacy small I, which is equal, ಇದನ್ನ left ಕಳಿಸಿ, total indeterminacy minus external indeterminacy. See, it is a total indeterminacy minus external indeterminacy. This is very, very important. In a simple problem, they may ask several things. Okay, first ಇದು ಅರ್ಥ ಆಯ್ತಾ? ಇದು ಇದರಲ್ಲಿ ಏನಾದ್ರು ಡೌಟ್ ಇದೆಯಾ? ನೆನ್ನೆ ಇದನ್ನ ನಾನು ಸ್ವಲ್ಪ ಫಾಸ್ಟ್ ಆಗಿ ಹೇಳಿದೆ ಲಾಸ್ಟ್ ಗೆ, ಸುಮ್ಮನೆ ನಿಮ್ಗೆ ಪ್ರೆಸೆಂಟೇಶನ್ ಹೇಗಿದ್ರು ಕಳಿಸ್ತೀನಲ್ಲ, ಇವತ್ತು ಪ್ರಾಬ್ಲಮ್ ಮಾಡ್ಬೋದು ಅಂತ. ಸೊ ಪ್ರೆಸೆಂಟೇಶನ್ ಎಲ್ಲರಿಗೂ ಸಿಕ್ಕಿದೆ ಅಲ್ವಾ? ಮೆಟೀರಿಯಲ್ ಸಿಕ್ಕಿದೆ ಅಲ್ವನ್ರಿ?
Yes, sir.
ಇವಾಗ ನೋಡಿ, ಇವಾಗ ಅರ್ಥ ಆಗುತ್ತೆ ನೀಟಾಗಿ. ಇವಾಗ ನೋಡಿ, ಈಗ ಇದ್ರಲ್ಲಿ ಏನಾದ್ರು ಡೌಟ್ ಇದೆಯಾ? ಈ ಈಕ್ವೇಶನ್ಸ್ ಬರ್ದಿರೋದ್ರಲ್ಲಿ ಏನಾದ್ರು ಡೌಟ್ ಇದ್ರೆ ಈಗಲೇ ಕೇಳಿ. ನಾನು ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ತಗೊಂಡಾಗ ಇನ್ನೂ ನೀಟಾಗಿ ಅರ್ಥ ಆಗುತ್ತೆ. ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. ಇದನ್ನ ಮಿಸ್ ಮಾಡಬೇಡಿ. ಇದನ್ನ ತುಂಬಾ ಚೆನ್ನಾಗಿ ನೋಡ್ಕೊಂಡ್ರೆ SD ಮತ್ತೆ MD ನಲ್ಲಿ ನೀವು ಈಸಿಯಾಗಿ ಒಂದು 2-3 ಕ್ವಶನ್ಸ್ ಇರ್ತವೆ ಅವರು. ಅದೆಲ್ಲ ಇದ್ರ ಬೇಸಿಸ್ ಮೇಲೆ ಇರ್ತದೆ. ಓಕೆ, shall I move on to the problems on these things?
Sir, number of equilibrium equations.
Number of equilibrium equations
For beams 2 ಆಗಿ ಬರುತ್ತೆ.
ಅದಾ ನೋಡಪ್ಪ, ಏನಂದ್ರೆ when we are taking beam, when you are considering beam ಹಿಂಗಿರುತ್ತಲ್ವಾ ಸ್ಟ್ರಕ್ಚರ್.
Yes, sir.
ಸೊ ಆಕ್ಸಿಯಲಿ ಆಕ್ಸಿಸ್ ನಲ್ಲಿ ನೋಡ್ಕೊ ನೀನು, ಒಂದು ಶಿಯರ್ ಪಾಸಿಬಲ್ ಇದೆ,
Yes, sir.
ರೊಟೇಷನ್ ಪಾಸಿಬಲ್ ಇದೆ. ನೀನ್
Yes, sir.
ಆಕ್ಸಿಸ್ ತಗೊಂಡಾಗ ಇದು ವಿತ್ ಇನ್ ದ ಆಕ್ಸಿಸ್ ಪಾಸ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ನಿಂಗೆ ಆಕ್ಸಿಯಲಿ ರಿಜಿಡ್ ಅಂತ ಬಂದಾಗ ಈ ಕೇಸ್ ಬರಲ್ಲ, ಎಲಿಮಿನೇಟ್ ಆಗೋಗುತ್ತೆ.
Yes, sir.
Then what are the equations? Fy equals 0, m equals 0 ಅಷ್ಟೇ.
Yes, sir.
ಆಯ್ತಾ? ನಿಂಗೆ ಇರೋದು ಅದೇ ತರನೇ ನಿಮ್ಗೆ ಅನಾಲಿಸಿಸ್. ನಿಮ್ಗೆ ಅಲ್ಲಿಗೆ ಬಂದಾಗ ಎಸ್ ಡಿ ಮತ್ತೆ ಎಂ ಡಿ ಹೇಳ್ತೀನಿ. ಓಕೆ,
ಮತ್ತೆ ಇದು ಟ್ರಸ್ಸಿಗೆ ಒಂದೇ ಬರುತ್ತಲ್ಲ ಸರ್?
ಟ್ರಸ್ಸಿಗೆ ಆಕ್ಸಿಯಲಿ ರಿಜಿಡ್. ತಡಿ, ಟ್ರಸ್ ನೋಡು, ಟ್ರಸ್ ಆಕ್ಸಿಸ್. ಟ್ರಸ್ ಅಲ್ಲಿ ನೀನು ದಿಸ್ ಇಸ್ ಅನ್ ಪಿನ್ ಜಾಯಿಂಟೆಡ್ ಟ್ರಸ್ ಅಂತ ತಗೊಂಡ್ರೆ ಟ್ರಸ್ ಇಸ್ ಎ ಆಕ್ಸಿಯಲ್ ಮೆಂಬರ್ ಅಲ್ವಾ?
Yes, sir.
ಇವಾಗ ನಿಂಗೆ ಹಿಂಗೆ ಎಫ್ ಅಂತ ತಗೊಂಡ್ರೆ,
Yes.
so if you are getting inclination, if you resolve this both fx and fy,
Yes, sir. Yes.
so ninge sigma, there are two equations of equilibrium. It's an axially rigid member. It's an
Yes.
axially rigid. Axially rigid means only sigma fx, sigma fy ella all
Fy.
are which pin jointed. All are pin jointed alva.
Pin.
Pin andre no, pin means what? So just
Moment
like a
is-
hinge.
Yes, sir.
So there are two equations. ಗೊತ್ತಾಯ್ತಾ?
Yes, sir.
ಅದೇ ರಿಜಿಡ್ ಪ್ಲೇನ್ ಫ್ರೇಮ್ಸ್ ಅಲ್ಲಿ ಇಟ್ಸ್ ಅನ್ 2D ಈ ತರ ಫ್ರೇಮ್ಗಳು, ರಿಜಿಡ್ ಪ್ಲೇನ್ ಫ್ರೇಮ್ಸ್ ಎಲ್ಲ ಹಿಂಗಿರ್ತದೆ.
Yes.
ಸೊ ಇಲ್ಲಿ ಆಲ್ ಆರ್ ಪಾಸಿಬಲ್.
Yes.
ಈ ತರ ಬಂದ್ರೆ ಆಲ್ 3 ಆರ್ ಪಾಸಿಬಲ್. ಎಲ್ಲಾರು ಯಾವ ಕಡೆಗಾರು ಮೂವ್ ಆಗ್ಬೋದು ಈ ಫ್ರೇಮ್. ಮೂರನ್ನು ನಾವು ರಿಸ್ಟ್ರಿಕ್ಟ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ.
Yes.
ಏನಪ್ಪ?
Okay, sir.
ಓಕೆ,
ಅಂದ್ರೆ ಎದ್ರ ಬಗ್ಗೆ?
ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್. ಲೆಟ್ ಮಿ ಮೂವ್ ಟು ದ ನ್ಯೂಮರಿಕಲ್ಸ್. ಓಕೆ, ಸಿಂಪಲ್ ಥಿಂಗ್, ಸಿಂಪಲ್ ಪ್ರಾಬ್ಲಮ್ ಇಂದ ಹೋಗೋಣ. ಫಸ್ಟ್ ವಿ ಟೇಕ್ ಬೀಮ್ಸ್. Okay, this is the given beam. Now, what is the equation for beams? What is the total indeterminacy equation?
2m plus
I equals
r
2m plus r
minus 2j.
2m plus r minus 2j. See, axially rigid. Generally, you are having axially rigid case. Okay, axially rigid means, see, if here you are having fixity, this fixed support will not allow to move this particular member in x-axis. Are you agreed with my statement? Because of this fixity, this member will not move anywhere. It is fixed. Here also, whenever there is a simple support, even though this particular beam will not move. Why? Because here you are having fixed support. Here you are having fixed support. ಅರ್ಥ ಆಯ್ತನ್ರಿ? ಈಗ ಬೀಮಿಂಗ್ ಇರುತ್ತೆ, ಇಲ್ಲಿ ನೀವು ಫಿಕ್ಸೋ ಇಲ್ಲ ಹಿಂಜ್ ಎರಡರಲ್ಲೊಂದು ಮಾಡೇ ಮಾಡ್ತಾರೆ. ಹಿಂಜಾರು ಫಿಕ್ಸ್ ಕೊಡ್ಲಿ, ಫಿಕ್ಸಿಟಿನಾರು ಕೊಡ್ಲಿ, ಏನಾಗುತ್ತೆ? ಇದೇನ್ ಮಾಡ್ಬಿಡುತ್ತೆ? ವಾಟ್ ಇಸ್ ದ ಡಿಫಾರ್ಮೇಶನ್ ಹಿಯರ್? ಆಲ್ ಆರ್ 0. ಸೊ ಬಿಕಾಸ್ ಆಫ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಮೆಂಬರ್ ವಿಲ್ ನಾಟ್ ಮೂವ್. ಸರಿನಾ? ಈ ಮೆಂಬರ್ ಮೂವ್ನೇ ಆಗಲ್ಲ. ಸರಿನನ್ರಿ?
ಹಾ ಸರ್.
ಇಲ್ಲಿ ಫಿಕ್ಸಿಟಿ ಇರೋದ್ರಿಂದ ಮೂವ್ ಆಗಲ್ಲ. ಯಾವ ಕೇಸ್ ಮೂವ್ ಆಗಲ್ಲ ಬೀಮು? ಇಲ್ಲಿ ಫಿಕ್ಸ್ ಇದ್ರೆ ಮೂವ್ ಆಗಲ್ಲ. ನೆಕ್ಸ್ಟ್ ಕೇಸು, ಹಿಯರ್ ಇಫ್ ಯು ಆರ್ ಹ್ಯಾವಿಂಗ್ ಹಿಂಜ್, if you even though if you are having roller is axially stiff, adu move agak bidalla. Okay, so generally we will assume this as axially rigid. That's why the equations of statics in generally we are considering as 2. Okay, illa sir nan 3 anta consider martini andre allow ಮಾಡಬೇಕು. I will explain 2 cases if you just observe this problem. Okay, here how much we consider 2. So this is what sigma fy and sigma m. ಸರಿನಾ? ಇದೀರಾ ಇಲ್ವಾ? ಸರಿನಾ? ಓಕೆ, Now,
Yes, sir.
how many members? I will consider only one example first. How many members?
2.
How many reactions? Here, 1, 2, 3. Here, 1, 1. Therefore, here you are having 3 reaction. Here you are having 1. Here you are having 1. What is the total external reaction?
5.
5.
What is number of joints? 1, 2, 3. What is the total number of joints?
3.
Substitute in this equation. How much? I. 2 into 2 plus 5 minus 2 into 3.
3.
How much? I equal
3.
3, sir, answer.
3. ಓಕೆ 3 ಬಂತಾ? ಇವಾಗ ನಾನು ನಿಮ್ಗೆ ಇನ್ನೊಂದು ಕೇಸ್ ಬರ್ತೀನಿ. ಇಲ್ಲಿ 2 ತಗೊಂಡೆ, ಸರಿನಾ? ಇಲ್ಲಿ 2 ತಗೊಂಡೆ, ಸೊ ನನಗೆ ಈ ತರ ಆಯ್ತು ಅಂದ್ರೆ here what we are assumed the thing is okay. So here what is this, internally or externally, ಅದನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. 3. ಓಕೆ, ಇವಾಗ ನಿಮ್ಗೆ you know that what is external indeterminacy? What is external indeterminacy?
R minus 2.
R minus 2. What is R? How much R?
5 minus 2.
5.
5 minus 2. Therefore 3. What is internal indeterminacy? Total I minus external. Total I is how much? 3. 3 minus 3 is 0. Hence, the given beam is indeterminate of order 3, in which it is externally indeterminate of order ಎಷ್ಟು 3 and internally what? Internally what?
No. 0. 0.
Not 0. You have to say that internally
Determinate.
determinate. ನಿಂಗೆ ಈ ಬೀಮ್ ಕೊಟ್ಬಿಡ್ತಾನೆ. ಈ ಬೀಮ್ ಕೊಟ್ಬಿಟ್ಟು ನಿಂಗೆ ಒಂದು 3 ಸ್ಟೇಟ್ಮೆಂಟ್ ಕೊಡ್ತಾನೆ. ಈ ಬೀಮ್ ಕೊಡ್ತೀನಿ. This beam is given. Now I will going to give 4 statements. A, beam is unstable. B, beam is externally determinate. C, beam is internally determinate. D, beam is indeterminate of order 2. Which one is correct?
C.
Which one is correct?
C.
C.
C. Why? This particular beam is internally indeterminate. Internally determinate, but externally
Indeterminate.
indeterminate of order
3.
3. ಈ ತರ ಎಲ್ಲಾರು ಏನಾರು ಹಾಕ್ಬೋದು ಅವನು. ಇಲ್ಲ ಅಂದ್ರೆ ಇಲ್ಲೇ ನಿಮಗೆ ಈ ಯಾವ ತರ ಆಪ್ಷನ್ ಕೊಡ್ಬೋದು. or else they may give like total indeterminacy of beam is 5, 8, 3, 2. What is the total indeterminacy of beam?
3.
3.
3. See, this is the answer. See, one problem na ಹೇಗ್ ಬೇಕಾದ್ರೂ ಸೆಟ್ ಮಾಡಬಹುದು ಅವರು. Any doubts? Any doubts? Yes, now I will give one more question. That is, please try to solve this question. Yes. Try to solve this question. Try to solve all the parameters. ಎಲ್ಲವನ್ನು ಮಾಡಿ. Try to solve all the parameters. Try to solve all the parameters. What are the parameters? Total indeterminacy. First find the total indeterminacy. Next find the external indeterminacy. Next find the internal indeterminacy and made a statement. And try to make a statement. So how many members? Now what is the equation? I equals 2m plus r minus 2j. Minus 2j. So total how many members? 3 members. How many joints? 1, 2, 3, 4 joints. How many external support reactions? How many external support reactions?
5.
1, 2, 3, 4, 5. Now from this we can say that members are 3, reactions are 5, joints are 4. Substitute these parameters to this equation. Try to get what is the value of I.
Three.
Yes, what is the value of I?
3.
3, sir.
3. Now what is external indeterminacy? Total reaction minus 2. What is the value? Five minus 2 is 3. Now this beam also internally.
Determinates.
Yes. Total indeterminacy minus external. So 0. So it is externally indeterminate. Okay. Now try to solve this. Try to solve this beam. Yes, how many members? 2. How many reactions? Here
7.
fixed support 3, 3, 1. So 7. So what are the joints?
2.
1, 2, 3 joints. So what is total indeterminacy? M plus R minus 2J. What is external indeterminacy? R minus 2. What is internal indeterminacy? Total indeterminacy minus external indeterminacy. Yes, determine all the things using these parameters. Yes, what is I value? Capital I?
7.
7. What is R?
5.
7.
R is also 7.
No, sir.
How much R? See, this is R is 2 plus 7 minus 6. 2 into J, 3. So total? How much?
2m, no, sir?
Sir, 2m.
2m, yes, 2m.
For beams 2m.
Yes, 2m plus r. How much?
5 sir.
5. Here
5
5.
sir.
This is 0. Okay. Generally beams are internally determinate and externally indeterminate. In few cases, you may get internally indeterminate. Okay. Now I will what I will do, I will go for some special condition. Some special condition. What are those special conditions? I will impose hinges. I will impose hinges, internal hinges. Internal hinges. These are special conditions. These are all internal hinges. Now, how to solve this problem? Now, this hinge will divide the member. It will allow the moment. So what happens? Now, how many members are there?
4
What are the
members.
total members?
4.
And what are the total joints? And what are the total reactions? The equation is 2m plus r minus 2j minus imposed conditions. Please take a note that if any imposed conditions are posed in the problem, you have to subtract the value in case of static indeterminacy, but in case of kinematic indeterminacy, you have to add. In case of kinematic indeterminacy, you have to add the imposed conditions. Now find out what is the I, what is the E. Remaining things are as usual. E equals r minus 2 and small I equals total indeterminacy minus external indeterminacy. Okay. See here, please make a note that this is a imposed condition within a member. Within a member, see, they will give like A, B, C. Okay, A, B, C is the beam. In this A, B span, this is the within the member, it is imposed. So you are not having any support. It's an internal imposed. Therefore, M is only 2. Don't take it as 1, 2, 3, 4. If you take 4, you are getting wrong answers. So this is a full member. That's why it's very, very important. This kind of problem generally they will ask. Okay. It is a member. It will make a joint, but it do not split the members. So what is the number of joints now? 1, 2, 3, 4, 5 joints. What is the reactions? 1, 2, 3, 3 plus 2, 5. How much we are getting? 2 into 2 plus 5 minus 2 into 5 minus 2. So 9. So we are getting negative.
-1, sir.
Minus
1.
minus 1. If you are getting minus, then you directly say that structure is unstable. Nothing. Optionally
-2.
negative bantu andre the structure is unstable.
Sir, -3.
Okay, whatever it may be, if you are getting minus thing, the structure is unstable. The structure is unstable. The structure is unstable. Godaita? When the structure is unstable, if you are
Then
getting, it's not a structure. It's not
10
a
minus
proper
1
kind of
minus 2
structure.
-1 -2
2x minus 2.
minus imposed condition ಮಾಡ್ಬೇಕಲ್ಲ
Imposed condition negative ಮಾಡಬೇಕು beam ಅಲ್ಲಿ. ಅದೇ in case of not beam, in case of static indeterminacy, in case of kinematic indeterminacy, you have to add the imposed conditions. You have to add the imposed condition. Generally, these are the possibilities. One, structure is unstable. Structure is determinate. Structure is statically determinate. Structure is statically, that is externally. Structure is externally determinate and internally indeterminate. Or structure is, this will come under structure is indeterminate. In structure is indeterminate, you are getting two things. One is structure is externally determinate, internally indeterminate, or structure is internally determinate and externally indeterminate. So ನಿಮಗೆ ಇಷ್ಟು ಆಪ್ಷನ್ ಅಲ್ಲಿ ಯಾವ್ದನ್ನಾರು ಅವನು ಬರೋ ತರ ಸೆಟ್ ಮಾಡಬಹುದು ಪ್ರಾಬ್ಲಮ್ಸ್. Structure is unstable or structure is determinate. In structure is indeterminate, you may get externally determinate, internally indeterminate, internally determinate, externally determinate, or both are indeterminate. Okay, so these are the general question generally asked in case of beams. Next we move on to trusses.
Sir, so previous problem, both it was externally and internally indeterminate, right?
In previous problem we are getting negative value. If we are getting negative value, it's unstable one.
No, sir, previous before this.
This one here.
Yeah. Yes, sir.
Here I is 0, right? This is internally determinate, externally indeterminate of order 5. See, external indeterminacy is 5. Total indeterminacy is also 5. Internal indeterminacy is 0.
Sir, internally I got 2, sir.
2. Please check.
0, sir.
Check this problem. (2m) plus r, that is 2 into 2 plus 7 minus 2 into 3. So 11, reading 5. Okay, so E equals total indeterminacy minus 2. Yes, 5 minus 2 is 3. Very good. So I equals I minus E. So 5 minus 3 is 2. Yes, this problem, the structure is both internally as well as externally
Indeterminate.
Sir,
yes,
sir,
r minus 2, right? This is r
seven.
minus 2. R is
7, sir.
7.
1.
So 7 minus 2 is
5.
5. See, once you check ಮಾಡಿ I minus 2 ಅಲ್ಲ, r minus 2.
Yes, sir. Okay.
Okay, please make your corrections. That is right. Previous answer is right. Okay, nothing to worry. If you make a mistake here, you can correct it. No problem. Okay, ಇಲ್ಲಿ ತಪ್ಪಾದ್ರೆ ಏನ್ ತಲೆ ಕೆಡಿಸ್ಕೋಬೇಡಿ, ಅದನ್ನ ಸರಿ ಮಾಡ್ಕೊಳ್ಳಿ ಎಲ್ಲಿ ಏನು ಅಂತ. ಅದಕ್ಕೆ ಒಂದು ಟೇಬಲ್ ರೆಡಿ ಮಾಡ್ಕೊಂಬಿಡಿ. ನೆನ್ನೆನೇ ಹೇಳಿದೆ ನಿಮ್ಗೆ. ಸೊ ಒಂದು ಟೇಬಲ್ ರೆಡಿ ಮಾಡ್ಕೊಳ್ಳಿ. You make a table.
Sir,
ಒಂದು ಟೇಬಲ್ ರೆಡಿ ಮಾಡ್ಕೊಂಡು ಅದನ್ನ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ ಅಷ್ಟೇ.
sir, I have a doubt, sir.
Yes, ಹೇಳಮ್ಮ.
Sir, in the problem which you solved just now, previously, can you just show me the slide? Yes, sir. So here, sir, can you please explain me how did you take that number of members? Like you took number of members as 2 here, but in case of frames, while you solve in case of frames, so the if there is internal hinge which is coming, so you take the members separately there. But in case of beams, you're not taking it separately. You just took the members as 2. So I have that doubt how to take.
Yes. Wait,
Yes, sir.
in case of frames, I think I have given this type of problem, right?
Yes, sir.
Here I have imposed the hinge.
Yes, sir.
If I impose the hinge, what happens? The joint and the hinge are imposing in the same point. On that case, it's a common point. So
Yes,
that's
sir.
why the number of joints are only 4. And in case of what happens, if it will create a moment, internal hinge will allow to rotate. Internal hinge will allow to rotate the member, but it will not create any kind of supports.
Okay.
Here, ನಿಮಗೆ separate ಆಗಿ beam ನ split ಮಾಡಲ್ಲ ಅದು. Within the member, it will try to allow the moment. ಅಂದ್ರೆ ನೀವು ಈಗ ಬ್ರಿಡ್ಜಸ್ ಅಲ್ಲೆಲ್ಲ ಸ್ಪ್ರಿಂಗ್ ಆಕ್ಷನ್ ಕೊಟ್ಟಿರ್ತಾರೆ ನೋಡಿದೀರಾ, ಬ್ರಿಡ್ಜ್ ಇಂದ ಬ್ರಿಡ್ಜ್ ಗೆ ಕನೆಕ್ಷನ್ ಕೊಡ್ಬೇಕಾದ್ರೆ ಮಧ್ಯದಲ್ಲಿ ರಬ್ಬರ್ ಹಾಕಿರ್ತಾರೆ. So on that case, it will behave as a single member, but it will allow the few moments. ಅದು ಮೊಮೆಂಟ್ ನ ಫುಲ್ ನಿಮ್ಗೆ ಸ್ಟ್ರಕ್ಚರ್ ಅಲ್ಲಿ ಅದನ್ನು ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡುತ್ತೆ ಕಾಲಮ್ ಗೆ ಇಮಿಡಿಯೇಟ್ಲಿ. ಸೊ ಆ ತರ ನಿಮ್ಗೆ ಮೆಂಬರ್ ನ ಡಿವೈಡ್ ಮಾಡಲ್ಲ ಅದು. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಮ್ಮ? ಮೆಂಬರ್ ನ ಡಿವೈಡ್ ಮಾಡಲ್ಲ ಅದು ನಿಮ್ಗೆ ಅಲ್ಲೇ ಜಸ್ಟ್ ಅಲೋ ಮಾಡುತ್ತೆ ಅಷ್ಟೇ. ಅಂದ್ರೆ ಆ ಸ್ಟ್ರಕ್ಚರ್ ಸಿಂಗಲ್ ಅದು, ಬಟ್ ಹ್ಯೂಜ್ ಮೊಮೆಂಟ್ಸ್ ಬಂದಾಗ ಜನರಲಿ ಏನ್ ಮಾಡುತ್ತೆ ಅದು ಅದನ್ನ ಅಲ್ಲೇ ಅಲೋ ಮಾಡ್ಬಿಡುತ್ತೆ. ಅದಕ್ಕೆ ನಾವು ಸ್ಟ್ಯಾಟಿಕ್ ಇಂಡಿಟರ್ಮಿನೆನ್ಸಿ ಅದನ್ನ ಮೈನಸ್ ಮಾಡ್ತೀವಿ ಇಂಪೋಸ್ಡ್ ಕಂಡೀಷನ್ ಅನ್ನ. ಬಟ್ ಕೈನಮ್ಯಾಟಿಕ್ ಇಂಡಿಟರ್ಮಿನೆನ್ಸಿ ನೀವು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಬಗ್ಗೆ ಮಾತಾಡೋದು. ವಿ ಆರ್ ಟಾಕಿಂಗ್ ಅಬೌಟ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಆಫ್ ದಿ ಸ್ಟ್ರಕ್ಚರ್. ದಿಸ್ ಇಸ್ ಸ್ಟ್ಯಾಟಿಕ್ ಇಂಡಿಟರ್ಮಿನೆನ್ಸಿ ಇಸ್ ದ ಒನ್ ಮೋರ್ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್, ಪ್ಲೀಸ್ ಟೇಕ್ ಎ ನೋಟ್. Static indeterminacy talking about forces. Static indeterminacy is force. So which is called force method also. Force method or flexibility method. ಇಷ್ಟು ಒಂದೇ ವರ್ಡ್. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಅದೇ ನಿಮ್ಗೆ ಕೈನಮ್ಯಾಟಿಕ್ ಇಂಡಿಟರ್ಮಿನೆನ್ಸಿ ಬಂದ್ರೆ this is talking about displacement. This is also called displacement method or stiffness method. These are all common words. These are all related to this only. ನಿಮ್ಗೆ PWD syllabus ಅಲ್ಲಿ ನಿಮ್ಗೆ ಇದು ಮಾತ್ರ ಇದೆ. You are not having static. ನಿಮ್ಗೆ ಏನು ಮೆಥಡ್ ಕೊಟ್ಟಿದ್ದಾನಲ್ಲ, ಸ್ಲೋಪ್ ಡಿಫ್ಲೆಕ್ಷನ್, ಮೊಮೆಂಟ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್, ಸ್ಲೋಪ್ ಡಿಫ್ಲೆಕ್ಷನ್, ಸ್ಟಿಫ್ನೆಸ್ ಮೆಥಡ್, ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಮೆಥಡ್. ನೀವು ಮೇಜರ್ ಆಗಿ ಇದು ಸುಮ್ಮನೆ ಬೇಸಿಕ್ ನೋಡ್ಕೊಳ್ಳಿ, ಈಕ್ವೇಶನ್ಸ್ ನೋಡ್ಕೊಳ್ಳಿ. ಕೈನಮ್ಯಾಟಿಕ್ ಇಂಡಿಟರ್ಮಿನೆನ್ಸಿ ನ ಜಾಸ್ತಿ ಫೋಕಸ್ ಮಾಡಬೇಕು. ಸೊ ಎನಿ ಡೌಟ್ಸ್?
ನೋ ಸರ್.
ಓಕೆ. ಈಗ ನೀವು ಈಗ ನಾನು ಏನ್ ಹೇಳ್ತೀನಿ ನಿಮ್ಗೆ, ಈ ಈಕ್ವೇಶನ್ಸ್ ನೆಲ್ಲ ಒಂದು ಲಿಸ್ಟ್ ಮಾಡ್ಕೊಂಬಿಡಿ. ಆಮೇಲೆ ಜಾಸ್ತಿ ತಲೆ ಕೆಡಿಸ್ಕೊಂಡು ಪ್ರಾಬ್ಲಮ್ಸ್ ಅಲ್ಲೇ ಇನ್ವಾಲ್ವ್ ಆಗಕ್ ಹೋಗ್ಬೇಡಿ. ನಿಮ್ಗೆ ಸಿಲೆಬಸ್ ನಲ್ಲಿ ಸ್ಪೆಸಿಫಿಕ್ ಆಗಿ ಇದು ಹಾಕಿಲ್ಲ. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ನಿಮ್ ಸಿಲೆಬಸ್ ನಲ್ಲಿ ಇರೋದು ಸ್ಲೋಪ್ ಡಿಫ್ಲೆಕ್ಷನ್ ಮೆಥಡ್, ಮೊಮೆಂಟ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಮೆಥಡ್ ಕ್ಲಿಯರ್ಲಿ ದೇ ಹ್ಯಾವ್ ಮೆನ್ಷನ್ಡ್. ಬಟ್ ಇದನ್ನು ಕೇಳೋ ಚಾನ್ಸಸ್ ಇದೆ, ತೆಗೆದಾಕಂಗಿಲ್ಲ. ದೀಸ್ ಆರ್ ಆಲ್ ಅಸೋಸಿಯೇಟೆಡ್ ವಿತ್ ದೋಸ್ ಮೆಥಡ್ಸ್. ಓಕೆ. ಸೊ ಅದಕ್ಕೆ ಏನ್ ಮಾಡಿ, ಈಕ್ವೇಶನ್ಸ್ ಸರಿಯಾಗಿ ನೋಡ್ಕೊಳ್ಳಿ. ಯಾವ್ದು ಈಕ್ವೇಶನ್ಸ್ ಇಂಪಾರ್ಟೆಂಟ್ ನಾನು ಇಲ್ಲಿ ಬರದ್ನಲ್ಲ, ದಿಸ್ ಇಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಇದನ್ನ ಟೇಬಲ್ ಅಲ್ಲಿ ಬರ್ಕೊಂಬಿಡಿ. ಸ್ಟ್ಯಾಟಿಕ್ ಇಂಡಿಟರ್ಮಿನೆನ್ಸಿ ಅಂತ ಒಂದ್ ಕಡೆ ಬರ್ಕೊಳ್ಳಿ, ಕೈನಮ್ಯಾಟಿಕ್ ಈ ತರ ಏನಂದ್ರೆ ಸ್ಟ್ರಕ್ಚರ್ ಅಲ್ಲಿ ಯಾವ್ಯಾವ್ದು ಬರುತ್ತೆ ನಿಮ್ಗೆ ಸ್ಟ್ಯಾಟಿಕ್ ಇಂಡಿಟರ್ಮಿನೆನ್ಸಿ. ಸ್ಟ್ರಾಟಜಿ ಮಾಡ್ಕೊಂಡು ಓದ್ಬೇಕ್ರಿ, ನಿಮ್ಗೆ ಕಡಿಮೆ ಟೈಮ್ ಇರೋದು. ಓಕೆ. ಇಫ್ ಯು ಹ್ಯಾವಿಂಗ್ ಎನಿ ಡೌಟ್ಸ್ ಯು ಕ್ಯಾನ್ ಆಸ್ಕ್ ಮೀ, ನಥಿಂಗ್ ಟು ವರಿ. Indeterminacy. In static indeterminacy, what are the possibilities? In static indeterminacy, what are the possibilities? Total indeterminacy, then external indeterminacy, then what is another one? Internal indeterminacy. Okay. First come to type of structure. What is the type of structure? And you may take members. Also, you may take static equations. Here you take first one, beam. In beams, what is the static equations? 2. In beams, what are the static equations? 2. How many members? 2m. So what is total indeterminacy? I equal this one, 2m plus r minus 2j. See, 2m plus r minus 2j. Or you can take truss first, no problem. If you take truss first, static equations are 2, number of members 1. So I equals m plus r minus 2j. Next you take frame. Frames. In frames, static equations are 3, members 3m. Therefore, I equals 3m plus r minus 3j. Here, external indeterminacy, this is reaction. External, I am talking about reaction. So, r minus static equation. R minus static equation. R minus static equation. So, once those two things are known, internal indeterminacy I is determined by total indeterminacy minus external indeterminacy. This is external indeterminacy E. This is total indeterminacy I. So any doubts? This is same. I equal small I minus E. I equals small I minus E. ಇತರ ಬರ್ದಿಟ್ಕೊಂಡ್ಬಿಟ್ರೆ ಸಾಕು. ನಿಮ್ಗೆ ಇಂಪೋಸ್ಡ್ ಕಂಡೀಷನ್ ಕೊಟ್ರೆ ಮಾತ್ರ ಮೈನಸ್ ಇಂಪೋಸ್ಡ್ ಕಂಡೀಷನ್ ಆಗುತ್ತೆ. ಕೊಟ್ರೆ ಜನರಲಿ ದೇ ವೋಂಟ್ ಆಸ್ಕ್. ಓಕೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಕೈನಮ್ಯಾಟಿಕ್ ಇಂಡಿಟರ್ಮಿನೆನ್ಸಿ ನಲ್ಲಿ ಏನಿದೆ ಈಕ್ವೇಶನ್ಸ್ ಬೀಮ್ಗೆ ನೆನ್ನೆ ಕೊಟ್ಟಿದ್ದೀನಿ. Or you can see the displacement chart. Directly we can write. Okay. Illa andre just I will try to explain. I'm having the slide. Slope deflection method it is. Okay. Here. This is based on equation. What is the equation for truss? dk equal 2j minus r. For beams and frames, dk equals 3j minus r. In truss, you are not getting any imposed condition. You may get imposed conditions in case of frames and beams. So right here. So what is the equation? So in case of beams, dk equals
3 times of j minus r.
3j minus r. In case of truss also, this is 2j minus r. In case of frame, 3j minus r. See, ಇಷ್ಟರ ಬರ್ಕೊಂಬಿಟ್ರೆ ಆಯ್ತು. ನೀವು ಇಷ್ಟನ್ನು ತಲೆಯಲ್ಲಿ ಇಟ್ಕೊಂಡಿರಿ. ಏನ್ ಕೇಳಿದ್ರು ನಿಮ್ಗೆ MCQ ಇರುತ್ತೆ, ಪಟ್ ಅಂತ ಈಕ್ವೇಶನ್ ಹಾಕಿ ಯಾವ ಆನ್ಸರ್ ಬರುತ್ತೆ ಟಿಕ್ ಮಾಡಿ. ಇಷ್ಟು ನೆನ್ಪಿಟ್ಕೊಂಡ್ರೆ ಸಾಕು. ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಪರ್ಟೈನಿಂಗ್ ಟು ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಟಾಪಿಕ್. ದಿಸ್ ಆರ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಟೇಬಲ್. ಇಷ್ಟಲ್ಲಿ ಇದ್ರೆ ಸಾಕು ನಿಮ್ಗೆ. Remaining things ಈಸಿಯಾಗಿ ಅರ್ಥ ಆಗುತ್ತೆ. Okay. If you want a few problems, I can take problems, or else I will move on to slope deflection method. ಏನ್ ಮಾಡ್ಲಿ? ಬೇಕು ಅಂದ್ರೆ ಒಂದೆರಡು ಪ್ರಾಬ್ಲಮ್ ಮಾಡಿಸ್ತೇನೆ, ಇಲ್ಲ ಅಂದ್ರೆ ಸ್ಲೋಪ್ ಡಿಫ್ಲೆಕ್ಷನ್ ಮೆಥಡ್ ಹೋಗ್ತೀನಿ. ಇಷ್ಟಿರ್ಬೇಕಷ್ಟೇ ನಿಮ್ಗೆ ಬೇಕಾಗಿರೋದು.
ಸರ್ ಒಂದೆರಡು ಪ್ರಾಬ್ಲಮ್ ಮಾಡಿ.
ಓಕೆ. Now I will move on to truss. See, ಅದನ್ನೇ ಕೈನಮ್ಯಾಟಿಕ್ ಇಂಡಿಟರ್ಮಿನೆನ್ಸಿ ಮಾಡ್ಬಿಡೋಣ. ಬೀಮ್ದು ಅದು ಮುಗ್ದೋಗುತ್ತೆ. So the kinematic indeterminacy is what? For beams, what is the decay equation? For beams, what is the decay equation?
For beams, 2j minus r.
2j minus r. ಈಗಿನ್ನು ಬರೆದ್ರಲ್ಲ
3j minus r.
Manasa.
3j minus r, right?
Yes, sir.
For beams and frames, 3j minus r. See how many joints?
3,
3 minus how many reactions?
5.
See here, you are not getting anything like internally kinematic, externally kinematic ಅಂತೆಲ್ಲ ಬರಲ್ಲ. It's a kinematic indeterminacy or degree of freedom ಅಷ್ಟೇ. ಅರ್ಥ ಆಯ್ತಾ? ಇದು ಒಂದೇ. ಇದಕ್ಕೆ unknown is 1. And also ನಿಮ್ಗೆ MCQ ಸಾಲ್ವ್ ಮಾಡಿದ್ನಲ್ಲಪ್ಪ, ನಿಮ್ಗೆ MCQ ಸಾಲ್ವ್ ಮಾಡುವಾಗ I remember we have marked statements ಅಲ್ಲಿ ಫ್ಲೆಕ್ಸಿಬಿಲಿಟಿ ಮೆಥಡ್, ಸ್ಟಿಫ್ನೆಸ್ ಮೆಥಡ್ ಅಂತ ಮಾತಾಡಿದ್ವಿ. ಜ್ಞಾಪಕ ಇದೆಯಾ? ನಿನ್ನೆನೋ ಮೊನ್ನೆನೋ ಮರ್ತೋಯ್ತಾ? ಜ್ಞಾಪಕ ಇದೆಯಾ? ಓಕೆ. ಹಿಯರ್ ಡಿಕೆ ಅಂದ್ರೆ ಕೈನೆಮ್ಯಾಟಿಕ್ ಇಂಡಿಟರ್ಮಿನೆನ್ಸಿ 1 ಬಂತು. ಸೇಮ್ ಸ್ಟ್ರಕ್ಚರ್ಗೆ ಸ್ಟ್ಯಾಟಿಕ್ ಇಂಡಿಟರ್ಮಿನೆನ್ಸಿ ಎಷ್ಟು ಬಂದಿದೆ?
Sir, 6 minus 5, sir.
ಏನಪ್ಪಾ?
Sir, 9 minus 5, sir.
9 minus 5 ಅಲ್ಲ. How much 9 minus 5?
4.
4. Okay. DS ಎಷ್ಟು ಬಂದಿದೆ? What is the static indeterminacy? Someone put a message. Static indeterminacy 4. Oh yes. Okay. Good. Okay. What is static indeterminacy?
2m plus r minus 2j.
2m plus r minus 2j. How much?
3.
3. So this problem, this structure, which method? This is force. This is force method. This is displacement. So now tell me which method is best suited for this problem? Which method is best suitable for this problem?
Force method.
Why?
Force.
Why? See, Nanginnu still I remember we have given 4 statements. Alva? Because see, the static indeterminacy is less than kinematic indeterminacy. On that case, static method is preferred. If the kinematic indeterminacy or displacement method prakara madak hodre, see here I am not getting 4. If you put equation, you are getting 4. But if I see the displacement, nan henge heltini here 0 0 0. Here because of this fixity it will not allow. Here you are getting only this, because of this reaction it is 0. You are getting theta. Here 0 0. Because of this fixity it will not allow, but this will allow. Here this is possible. So if I take A, B, C, theta B, theta C. So what are the unknowns? Kinematic indeterminacy are only 2. But if you put to equation, how much we got? How much we got? Yes, ಹೇಳಿ ಎಷ್ಟು ಬಂದಿದೆ?
4.
4. Why? What is the reason? ಈ ಡಿಫರೆನ್ಸ್ ನಿಮಗೆ ಬರಬೇಕು. What is the reason? See, here what we have written the equation with reference to equilibrium equations as well as external support reactions. But if you observe the displacement, this is degree of freedom. This is called degree of freedom. Degree of freedom. So there are 2 technical terms. This is called kinematic indeterminacy. So when you are getting MCQ questions, you have to verify for both the things. ಕೆಲವು ಟೈಮ್ ನಿಮಗೆ 4 ಬರುತ್ತೆ, 4 ಆನ್ಸರ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಬಟ್ ಅವ್ನು ಏನ್ ಕೇಳಿದಾನೆ? ಡಿಗ್ರಿ ಆಫ್ ಫ್ರೀಡಮ್ ಕೇಳಿದಾನ, ಕೈನೆಮ್ಯಾಟಿಕ್ ಇಂಡಿಟರ್ಮಿನೆನ್ಸಿ ಕೇಳಿದಾನ, ಚೆಕ್ ಮಾಡಬೇಕು. ಅರ್ಥ ಆಯ್ತಾ? ಅವ್ನು ಕೈನೆಮ್ಯಾಟಿಕ್ ಇಂಡಿಟರ್ಮಿನೆನ್ಸಿ ಕೇಳಿದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ಲೈಕ್ ದಿಸ್ ಓನ್ಲಿ. ಇದೇ ತರ ಮಾಡಬೇಕು. ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಹೇಳ್ಕೊಟ್ಟಿದ್ದೀನಲ್ಲ, ಫಿಕ್ಸಿಟಿಲಿ ಬಿಕಾಸ್ ಆಫ್ ಆಲ್ 3 ರಿಯಾಕ್ಷನ್ 0 0 0 0. ಸೊ ಇದೇ ನಿಮಗೆ SD ಮೆಥಡ್, MD ಮೆಥಡ್ ಅಲ್ಲಿ ನಾವು ಇದೇ ತರ ಮಾಡೋದು. ನಾವೆಲ್ಲೂ ಈಕ್ವೇಶನ್ಸ್ ಯೂಸ್ ಮಾಡಲ್ಲ, ಬಿಕಾಸ್ ದಿಸ್ ಇಸ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಮೆಥಡ್. ಬಟ್ if we ask in a question what is degree of freedom, then you must be use equation only. Degree of freedom. This is possible degree of freedom. But ಎಲ್ಲೋಯ್ತು ಎರಡು ಎಲ್ಲೋಯ್ತು ಇದು? Because of this fixity ಇವೆರಡು 0 ಆಗಿದೆ. ಎಲ್ಲೂ ಹೋಗಿಲ್ಲ, ಅಲ್ಲೇ ಇದೆ. ಇನ್ನೂ ಅರ್ಥ ಆಗ್ಲಿಲ್ವಾ? Have you got the difference? See, if you observe ಇಲ್ಲೇ ಇದೆಯಲ್ಲಪ್ಪ, ಇಲ್ಲಿ 4 ಬಂತು ಈಕ್ವೇಶನ್ ಹಾಕ್ದಾಗ. ಏನಕ್ಕೆ? ದಟ್ ಇಸ್ ಡಿಗ್ರಿ ಆಫ್ ಫ್ರೀಡಮ್. ಅಂದ್ರೆ ಅಷ್ಟು ಪಾಸಿಬಿಲಿಟಿ ಇದೆ ಅಂತ ನೀವು ಹೇಳ್ತಾ ಇದ್ದೀರಾ. ಬಟ್ ಇಫ್ ಯು ಸಿ ದಿ ಪ್ರಾಕ್ಟಿಕಲಿ ವಾಟ್ ಇಸ್ ದ ಇಂಡಿಟರ್ಮಿನೆಸಿ? Because of this fixity axially rigid, it will not allow to move the member. It's a real. If I talking about freedom, ಎಲ್ಲ ಆಯ್ತದ ರಿಯಲ್ ನಂಗೆ ಬೇಡ, ಎಷ್ಟು ಆಕ್ಷನ್, ದಟ್ ಇಸ್ ಡಿಗ್ರಿ ಆಫ್ ಫ್ರೀಡಮ್. ನಾವು ಕೈನಮ್ಯಾಟಿಕ್ ಇಂಡಿಟರ್ಮಿನೆನ್ಸಿ ಎಕ್ಸಾಕ್ಟ್ ಎಷ್ಟು ಆಗ್ತಾ ಇದೆ ಗೊತ್ತಾಯ್ತಾ ಇಲ್ವಾ? ಓಕೆ, ಐ ವಿಲ್ ಗಿವ್ ಒನ್ ಮೋರ್ ಎಕ್ಸಾಂಪಲ್. ಪ್ಲೀಸ್ try to find both dk as well as kinematic indeterminacy for the given structure. What is dk?
DK is 4.
dk is 3j minus r. So 3, 1, 2, 3, 4, 12 minus 6 plus 2, 8. 12 minus 8 and 4. Have you got
Yes,
4?
sir. Yes, sir.
Okay, what is ki? Ki ಮಾಡ್ಬೇಕಾದ್ರೆ ಏನ್ ಮಾಡಬೇಕು? At each joint you have to mark possible displacement. At each joint 3 displacements are possible. At each joint or at each support 3 possible displacements. But because of this fixity, what is the reaction? How much? 3 reactions. Here, because of fixity, how many reactions? 3 reactions. These 3 reactions will not allow to move these 3 displacements. These 3 reactions will not allow to move these 3 displacement. Because of this vertical, it will not allow to move vertical displacement. Because of this vertical reaction, this is not allowed to move vertical reaction. This theta is allowed. This theta is also allowed. So this is b, theta b, theta c, theta b and theta c, theta b and theta c. See, but this particular, because of this 2 ends are fixed, this reality, this axially rigid now, it will not allow to move the member within the member because of there are 2 fixity. Therefore, this is also 0. This is also 0. The kinematic indeterminacy is 2, theta b and theta c. See, actually, if I consider this, this is also possible. This is also possible. In degree of freedom, the actual degree of freedom is 4, right? But because of these 2 fixed supports, these 2 are eliminated. That's why we got 2. So in your question paper, if they ask kinematic indeterminacy, the answer is 2. In your question paper, if they ask degree of freedom, the answer is 4. Now, any doubts?
Sir, kinematic indeterminacy ಮತ್ತೆ
Yes.
DK ಅಂದ್ರೆ ಸೇಮ್ ಅಲ್ಲ?
dk is nothing but kinematic indeterminacy. See, that is nothing but degree of freedom is nothing but kinematic indeterminacy. But in practical situations, you have to see. Wait, I will show you. See, this is degree of freedom. This is kinematic indeterminacy. In kinematic indeterminacy, see, this is degree of freedom we are going to considering with respect to what we are comparing displacement. See, these are the displacement. Now, what is the degree of freedom? What is the degree of kinematic indeterminacy? Here, kinematic indeterminacy is theta b, theta c. But for the same problem, what is degree of freedom? 3j minus
R.
R. Now 3 into joints are 3 minus R 1, 2 plus 3, 5. How much?
4.
3
4.
joint 9. 9 minus 5, 4.
4.
See, now we got, this is degree of freedom. This is the possible degree of freedom, possible moment of supports, possible moment of supports. But what happens because of this fixity? It is getting 0. Here also, because of this fixity, this is also 0. Now 4 minus 2, 4 minus 2. Because those two are eliminated. How much? This is actual kinematic indeterminacy. So there is a simple logic. Degree of freedom anta kotre full ella consider ಮಾಡಬೇಕು. So ಅದಕ್ಕೆ ನೀವೇನು ಈ ತರ ಮಾಡಕ್ಕೆ ಹೋಗ್ಬಿಡಬೇಡಿ. ಆಗ ಡಿಗ್ರಿ ಆಫ್ ಫ್ರೀಡಮ್ ಅಂತ ಕೊಟ್ಟಾಗ ಇಲ್ಲಿ 0 ಮಾಡಕ್ಕೆ ಹೋಗಬೇಡಿ. ಅವಾಗ ಬರೀ ನೀವೇನ್ ಮಾಡಬೇಕು? You have to read this concept, degree of freedom for different support conditions. Now ಇಲ್ಲೇ ನೋಡಿ ನಿಮ್ಗೆ ಸೇಮ್ ಆನ್ಸರ್ ತೆಗಿಸ್ತೀನಿ. Here fixity, how many reactions? ನೀವೇ ಹೇಳಬೇಕು.
3.
Fixity, how many reactions?
3.
3. Therefore, what is the degree of freedom?
0.
0. Here, you don't see the beam. You don't see the beam. Just see the support. Here, how many reactions are there?
1.
Therefore, vertical is 0. It is possible and it is possible. Now, here, how many reactions are there?
1.
1. So this is 0. This is possible. This is possible. What is degree of freedom now?
4.
4. Now apply your equation. What is your equation?
3j minus R.
3m minus r.
3j minus R.
3j minus r. 3j minus r. Apply 3j minus r. 3 into 3 minus 5. So how much you are getting?
4.
See, clear? If you are looking only the given support, then we term it as degree of freedom. If we are looking only the particular support, that is termed as degree of freedom. If you look the beam holistically as a single member, now, if you look at this beam as holistically a single member, now tell me, here 0, 0, 0. Here, this is 0. Because of this fixity, strictly speaking, the member will not move. Hence, this is 0. The possible is only theta. Here also, because of this fixity, it will not move. Because of the reaction, it will not move. Theta. Now, this is termed as kinematic indeterminacy. So, when we are talking about kinematic indeterminacy, we are talking about the entire structure. Now, what is kinematic indeterminacy? Kinematic indeterminacy is 2. That is theta. Here 1 and 2. So, any doubts? Any doubts?
Okay, sir.
Clear? See, if he is asking kinematic indeterminacy of the structure, you have to see entire beam. If he is asking degree of freedom, you have to see individual joints. ಅರ್ಥ ಆಯ್ತಾ? ಎರಡು ಟರ್ಮ್ಗೂ ನಿಮ್ಗೆ ಅಲ್ಲಿ ಎಕ್ಸಾಮ್ ನಲ್ಲಿ ಎರಡನ್ನೂ ಹಾಕ್ಬೋದು. ಎರಡರಲ್ಲಿ ಯಾವ ತರ ಬೇಕಾದ್ರೂ ಕೇಳ್ಬೋದು. ಕ್ಲಿಯರ್ ಆಯ್ತಪ್ಪ? ಡೌಟ್ ಇದ್ರೆ ಕೇಳ್ಬೇಕು ಸ್ಪೆಸಿಫಿಕ್ ಆಗಿ, ಸರ್ ನಂಗೆ ಇಲ್ಲಿ ಅರ್ಥ ಆಗ್ತಾ ಇಲ್ಲ ಅಂದ್ರೆ ಐ ವಿಲ್ ಎಕ್ಸ್ಪ್ಲೈನ್. ಓಕೆ, ನೌ okay, what is the truss? Now, what is the truss? In truss, you are having determinate truss or redundant, or so in truss we are having. So all those things is not required now. So we just try to get static indeterminacy and kinematic indeterminacy of the truss. That's enough. Yes, this is the given truss member. Now, what is the equation of truss for total indeterminacy? Static indeterminacy I equals m plus
Two.
r minus
2J.
2j. So how many members are there? 1, 6 members. How many joints are there? 5 joints. How many reactions are there? This is hinge, 2 reactions. This is roller, 1. Total 3. Now if you substitute here, 6 plus 3 minus 2 into 5. How much? Here 7 members.
7
or
sir.
6 members.
7 sir. Elon miss
1, 2,
ಮಾಡಿದೆ sir.
here I have missed 1. So 7 members. 7. So here 0. So what it means? The given truss is what? Endre
Statically
determinate truss.
Determinate.
It is also called perfect truss. So generally, for your analysis, you are having only perfect truss. You are having only perfect truss. You are having only perfect truss. I will give one more example. Yes, try to find the I value for this truss. What is I? Number of members is how much? Number of reactions? Number of joints?
-1.
Minus 1. Minus 1. Minus 1. Therefore, M is, if you see this, M is less than 2j minus r. I have revised this equation. M plus r equals 2j. M plus r minus 2j. I'm taking, if you are equating 2j minus r, m equal 2j minus r. Number of members are m equals 4. If you do 2j minus r, how much you are getting? 2 into j is 8. 8 minus r 3. Number of members is 4. We will examine this. Less than or greater than, later we will decide. 2 into 4 minus 3. So 4, 5. So this is 5 we got, right? 8 minus 3, 5. So M is less than 2j minus r, which means this type of truss is called, which type of truss this is now? M less than 2j minus r. M equals, see, if you observe this, it will become M equal 2j minus r. This is perfect truss. Idnu kela chances ide. If what is meant by perfect truss? Perfect truss means M equal 2j minus r. You just see here, M is 7. 2 into j, number of joints are 5, minus reaction is 3. 10 minus 3, 7 equals 7. So this is called perfect truss. So for this kind of structures, you are getting I equals 0. Now this truss is called deficient truss. Deficient truss. Kadame aito. This is called deficient truss. Now I will give one more example. I will give one more example. I will give one more example. Take this determinant. Yes, ಹೇಳಬೇಕು. How many members?
6.
6. How many joints? 4. How many reactions? 3. Now tell me M 2j minus R. Members are 6. 2 into 4 minus R. 6. 8 minus 3. 6. 5. Therefore, this is M is greater than 2j minus R. What it indicates? This is called
Redundant frame.
redundant truss. See, ishtu basics nim tallalirli, but you are having only perfect truss. ಅವನು ನಿಮಗೆ ಹಿಂಗೆ ಕೇಳ್ಬಿಡ್ತಾನೆ, if the condition for redundant truss is ಅಂತ ಅವೆಲ್ಲ ಕೊಡ್ತಾನೆ, 3M 2M ಏನೇನೋ ಕೊಡ್ತಾನೆ. ನೀವು ಅದನ್ನ ನೋಡ್ಕೊಂಡು ಹಾಕ್ಬೇಕು. ಗೊತ್ತಾಯ್ತಾ? ಟ್ರಸ್ ಅಲ್ಲಿ ಇಷ್ಟು ಗೊತ್ತಿದ್ರೆ ಸಾಕು ನಿಮಗೆ. ಎನಿ ಡೌಟ್ಸ್? ಎನಿ ಡೌಟ್ಸ್? ನೋ ಡೌಟ್ಸ್. ಓಕೆ, ಬರ್ಕೊಂಡ್ರ ಇದನ್ನ? ಟ್ರಸ್ಟ್ ಆಯ್ತಾ? ನೆಕ್ಸ್ಟ್ ಹೋಗ್ಲಾ?
Yes, sir.
ಓಕೆ, ಸಿ ದೀಸ್ ಆರ್ ಆಲ್ ನೆನ್ನೆ ನಿಮಗೆ ಜಸ್ಟ್ ಹಾಫ್ ಅನ್ ಅವರ್ ಅಲ್ಲಿ ಗ್ಲಾನ್ಸ್ ಮಾಡಿದ್ದೆ, ಇವಾಗ ಡೀಟೇಲ್ ಆಗಿ 1.5 hour ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದ್ದೀನಿ. ಆಯ್ತಾ? ಓಕೆ, ನಾವು ವಿ ವಿಲ್ ವಾಂಟ್ ಟು ಫ್ರೇಮ್. ಒಂದು ಸಿಂಪಲ್ ಫ್ರೇಮ್ ತಗೊಂಡ್ಬರೋಣ, ಆಮೇಲೆ ಒಂದು 5 minutes ಬ್ರೇಕ್ ಕೊಡ್ತೇನೆ. 5 minutes ಬ್ರೇಕ್ ಆದ್ಮೇಲೆ ಬನ್ನಿ, ವಿ ವಿಲ್ ಮೂವ್ ಆನ್ ಟು ಸ್ಲೋಪ್ ಡಿಫ್ಲೆಕ್ಷನ್ ಮೆಥಡ್. ವೆರಿ 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 ಇಂಪಾರ್ಟೆಂಟ್ ಟಾಪಿಕ್. ಓಕೆ?
Yes.
ಓಕೆ, ಒಂದು ಸಿಂಪಲ್ ಫ್ರೇಮ್ ಮಾಡೋಣ ಸಾಕು, ಅದೇನು ಜಾಸ್ತಿ ಕೇಳಲ್ಲ ನಿಮ್ಗೆ, ಬಟ್ ಹೇಳಕ್ ಆಗಲ್ಲ. ಇಟ್ಸ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ಸೆಕ್ಟರ್. Yes. Determine I value. What is the equation?
Three M minus 3J. 3M.
How many members? How many joints? How many reactions? 6. How much? 24 minus 18, 6. Have you got 6? Now verify what is the external indeterminacy. That is R minus 3. So 6 minus 3. 3. What is internal indeterminacy? Total indeterminacy minus external. 6 minus 3. Therefore, the given frame is, sorry, the answer.
3.
Please check the answer.
Correct, sir.
Externally and
Internally.
internally
Indeterminate.
indeterminate by degree
3.
3. See, ನಿಮಗೆ ಈ ಸ್ಟ್ರಕ್ಚರ್ ಹಾಕ್ಬಿಟ್ಟು ಕೊಟ್ಬಿಡ್ಬೋದು ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ. ಡಿಟರ್ಮಿನೇಟ್, ಸ್ಟ್ಯಾಟಿಕಲಿ ಎಕ್ಸ್ಟರ್ನಲಿ ಡಿಟರ್ಮಿನೇಟ್, ಇಂಟರ್ನಲಿ ಇಂಡಿಟರ್ಮಿನೇಟ್, ಬೋತ್ ಇಂಟರ್ನಲಿ ಅಂಡ್ ಎಕ್ಸ್ಟರ್ನಲಿ ಇಂಡಿಟರ್ಮಿನೇಟ್, ಯಾವ್ದಾದ್ರು ಆಪ್ಷನ್ಸ್ ಕೊಡ್ಬೋದು. ಸೊ ಎನಿ ಡೌಟ್ಸ್?
No, sir.
Please try to get this for this problem. It's very simple one. Try to get answer for this simple frame. One hinge, one fixity. This is fixity and this is hinge. Yes, how much? What? Just tell me the answers. What is I value?
Two.
What is E value?
Two,
And what
two
is small
sir.
I?
I value is 2.
2. E is?
Small E is 2.
E is also 2.
Yes, sir.
I is 0.
0.
See, you just observe. I made a small thing. I have changed the boundary condition. Boundary condition is nothing but support condition. See, it will become externally determinate, externally indeterminate, internally determinate. See how the difference you gather, observe ಮಾಡ್ಕೋಬೇಕು ಯಾವ ತರ changes ಆಗ್ತಾ ಇದೆ ಅಂತ. See, for the same frame, see, we will check once. For the same frame, if I make hinge, yes, now what will it, ಈ frame ಏನಾಗ್ತದೆ? Multi story frame, 1/2 story. ಏನಾಗುತ್ತೆ ಇದು?
5 ಆಗುತ್ತೆ.
I have made a just change, single change. I have made this hinge now. Yes, what is the value of I? And what is the value of E? And what is the value of small I?
5. Sir, 5 ಆಗುತ್ತೆ.
I is 5.
Yes, sir.
What is E?
2 ಆಗುತ್ತೆ.
E is 2.
Yes, sir.
What is small I then? 3.
Yes, sir.
See, ಅಲ್ಲೊಂದು ಸ್ಮಾಲ್ ಚೇಂಜ್ ಮಾಡಿದ್ದು, ಇಲ್ಲಿ ನಿಮ್ಗೆ ಈಕ್ವೇಶನ್ಸ್ ಚೇಂಜ್ ಆಯ್ತು, ನಂಬರ್ಸ್. Now what I will do here, I will do hinge now. Both are hinges now. ಇವಾಗ ಏನಾಯ್ತು? ನೀವು ಈ ತರ ಡಿಫ್ರೆಂಟ್ ಮಾಡಿ ನೀವು ಒಂಥರ ಒಂದು ಲಾಜಿಕಲ್ ಥಿಂಗ್ ತಲೆಯಲ್ಲಿ ಇಟ್ಕೋಬೇಕು. ಅಲ್ಲಿ ನಿಮ್ಗೆ ಟಿಕ್ ಹಾಕೋದಕ್ಕೆ ಸುಮ್ಮನೆ ಟೈಮ್ ವೇಸ್ಟ್ ಆಗ್ಬಾರ್ದು. ಎಸ್, ನಾವು ಇವಾಗ ಏನಾಗುತ್ತೆ? What is I, what is E, and what is small I?
4 ಆಗುತ್ತೆ ಸರ್.
I is 4.
4 1 3.
R is 4.
1 ಆಗುತ್ತೆ ಸರ್.
ಎಷ್ಟಪ್ಪ?
ಸರ್ I 4 E 1 ಆಗುತ್ತೆ ಸರ್.
So this is 3.
3. Yes, sir.
ನೀವು ಏನ್ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಿದ್ದೀರಾ? ವಾಟ್ ಎವರ್ ದ ಥಿಂಗ್, ಇಂಟರ್ನಲ್ ಇಂಡಿಟರ್ಮಿನೆಸಿ ಸೇಮ್ ಹಂಗೆ ಇದೆ, ಎಕ್ಸ್ಟರ್ನಲ್ ಇಂಡಿಟರ್ಮಿನೆಸಿ ಮಾತ್ರ ಚೇಂಜ್ ಆಗ್ತಾ ಇದೆ. So what you are varying external support conditions. That's why external indeterminacy is varying. So what the conclusion they make, you may ask. So for this thing, external support reactions are directly proportional to external indeterminacy. ಅರ್ಥ ಆಯ್ತಾ ಸ್ಟೇಟ್ಮೆಂಟ್? External support reactions are directly proportional to external indeterminacy. Indirect ಆಗಿ ನಾನ್ ಸೆಟ್ ಮಾಡಿದ್ರೆ ಆ ತರ ಕ್ವಶನ್ಸ್ ಹಾಕ್ತೀನಿ ಆರಾಮಾಗಿ. How given structure ಕೊಟ್ಬಿಟ್ಟು, if the external indeterminacy of the structure depends on, the external indeterminacy of the structure depends on, first option, number of members. B, boundary conditions. C, internal forces. D, none of the above. So which one is the answer? Boundary conditions. So external indeterminacy depends on, please take a note, external indeterminacy depends on boundary conditions of the given structures. ನಿಮ್ಗೆ ಏನಿದು ಏನೋ ಬಂತಲ್ಲ, ಇದೇನು ನಮ್ ಸರ್ ಹೇಳ ಇಲ್ವಲ್ಲ ಅಂತ ಅನ್ಕೋಬಾರ್ದು. ನೀವು ಅದಕ್ಕೆ ವೇರಿಯಿಂಗ್ ಮಾಡಿ ಈ ವ್ಯಾಲ್ಯೂಸ್ ಹೇಳಿದ್ ನಿಮ್ಗೆ. ಇಂಟರ್ನಲ್ ಇಂಡಿಟರ್ಮಿನೆಸಿ ಸೇಮ್ ಇರುತ್ತೆ. Clear? Any doubts? Any doubts? Okay, just take 5 minutes of break now. At exact 7:30 or 7:32, we will take slope deflection methods. Very, very important topic. Thank you. If you are having any doubts, you can ask. Move on to slope deflection method. So here you are having two methods to determine final moments as well as deflections. That is having
ಏನಂತದೆ
slope deflection method and moment distribution method.
ಇರ್ಲಕ್ಕ 1,00,000 ಹಾಕ್ತಿರಲ್ಲ 15,000
First, we will move on to slope deflection method. These two methods are very, very important in the for the exam point of view. Especially, they are specifically mentioned these two methods only in indeterminate structural analysis. This is related to your analysis of indeterminate structures. Indeterminate structures. That's why we discussed a lot of things regarding in previous structures with respect to indeterminacy. Why? Because these two topics are mainly related to indeterminate structural analysis. These two topics are mainly related to indeterminate structural analysis. Now tell me, give me an example for indeterminate structural beams, especially you are having here beams and frames. Beams and frames. There are two kinds of problem you may expect. Problem means basics. Beams and frames. Okay, give me an example for indeterminate structural beams. What are the example for indeterminate structures? Beams. Indeterminate beams. What are indeterminate beams? Give me example.
Fixed beams,
Fixed beam. Very good.
prop cantilever,
Propped cantilever beam. Fixed beam, continuous beam, as well as overhang. Sometimes you may get like this overhang, right? These are all indeterminate structures. See, in your syllabi they have specifically mentioned propped cantilever, continuous, like that only they have mentioned. So which means that you are getting very simple questions. So if you know how to solve the problems, what are the very important steps involved in slope deflection method as well as in moment distribution method, then you may attempt n number of MCQs, nothing to worry about the things. Okay. So now what are indeterminate beams? So here how we identified this as indeterminate? Because here we are having 3 external support reaction, here 1, total is 4. Available equations are 3, therefore 4 greater than 3, hence it is indeterminate. Here 3 plus 3 6 is greater than, available equations are 3, hence it is also indeterminate. Here 3 1 1 1, therefore 6, which is also greater than, available equations are only 3. What are available equations? 3 equations are sigma h equals 0 or sigma fx equals 0, sigma v equals 0 and sigma m equals 0. Here 3 1 1, so 5 greater than 3. So hence these structures are indeterminate structures, indeterminate beams. Any doubts in this? Any doubts? Okay, now we move on to this particular method, slope deflection method. See here, I am not ready to wasting time because by deriving the equations, it's all not important. You must remember the final equation. You must remember the final equation. That is for final moment, final computation of final moment, we are going to use this equation. Say for an I'm considering the AB. I want to determine what is the final moment developed in AB as well as BA. Then this equation is adopted. MAB equals MFAB or MAB bar, both are same, fixed end moment. MFAB plus or minus, or you just take plus, no problem. 2EI by L multiplied by 2 theta A plus theta B minus 3 delta by L. Similarly, for BA member, MBA equals MFBA plus 2EI by L into 2 theta B plus theta A minus 3 delta by L. Please take note this equation. This is very, very important. This is the final slope deflection equation. This is the final slope deflection equation. Very, very important thing. Here, what is MAB? What is MAB? What is MAB? MAB is final moment in member AB. MBA is final moment in member BA. What is MFAB? MFAB equal
force in member AB.
Fixed, not force, fixed moment. Fixed moment in member AB. Similarly, MFBA is fixed moment in member BA. Now, what is theta B and theta A? What is theta B and theta BA? Rotations at B and A, or in other words, it is called kinematic indeterminants. Then definitely this is displacement method. Why we are talking about this displacement, theta A, theta B? So all kinematic indeterminants. Hence, this method is displacement method. Slope deflection method is displacement method. You may get a question. Slope deflection method or moment distribution method is force method, flexibility method, stiffness method, or compatibility method, some other thing. So on that case, you have to choose displacement method or stiffness method. Both are same. This particular methods are stiffness or displacement methods. Displacement methods. And theta A, theta B is what? Delta. Delta is, in case of beams, sinking contribution. Sinking in case of beams. Delta is sway in case of frames. See, there are two terms. Confusion ಮಾಡ್ಕೋಬೇಡಿ. beam ಅನ್ನ sway ಅಂತ ಹೇಳಬಾರ್ದು. beam ಏನಾಗುತ್ತೆ, ಕೆಳಗಡೆ ಬರುತ್ತೆ, ಸಿಂಕ್ ಆಗುತ್ತೆ. ಫ್ರೇಮ್ ಏನಾಗುತ್ತೆ, sway ಆಗುತ್ತೆ. beam horizontally down ಬರುತ್ತೆ, ರೈಸ್ ಆಗುತ್ತೆ ಇಲ್ಲ ಸಿಂಕ್ ಆಗುತ್ತೆ. ಫ್ರೇಮು ಸ್ವೇ, ಕಾಲಮ್ ಸ್ವೇ ಆಗೋದು ಫ್ರೇಮ್ ನಲ್ಲಿ. ಅಂದ್ರೆ ವಾಟ್ ದ ಥಿಂಗ್ ಇಸ್, if this is a beam, if I am mentioning that the support B will sinks by 2 mm, see this is the real beam, mentioning that the support B sinks by 2 mm, so this is called sinking, not sway. This is called sinking. Or I may give rises by, support C rises by 2 mm. On that case, you have to take like this, support B sinks by 2 mm. Now it will come to here 2 mm and then it will goes to here. So this is called rising and this is called sinking. Sinking, however they may set, but thing is you have to observe always supports will sink in case of beams or rises in case of beams. But if you come to column, if you come to frames, the frame will sway. This is delta. Same amount, delta. So this is called sway. So please keep in your mind, beams we are not terming as sway, in frames only, and also columns are only under sway. Beams will not come in sway condition. Sway in terms we are terming in columns, that is in frames. Sinking we are terming it in beams, in case of beams. It's very, very important thing. Okay, so beams sinks, column sways. Now sometimes they may ask MCQ with relevant to equation. What is the equation? MAB equals
MFAB plus 2EI by L 2 theta A plus theta B minus
3 delta by L. Here there are so many things involved. I will try to give a few of the aspects. Okay, now you just observe here, sometime MCQ it will appear, sometime they may ask in MCQ. See here, this is fixed end moment where MFAB is fixed end moment. See what is mean by fixed end moment? What is mean by fixed end moment? Say for an example, I am giving a structure like this for analysis. Analyze the given beam using MD method or ST method. Here I have given UDL, here I have given point load. So initially the spans are assumed to be fixed. So here I have to assume the span as fixed when we are doing MAB. So when I am assuming, so I am considering first one by one case. I am assuming, then here I am having the point load W acts at L by 2 and L by 2 exactly at center. Now what is fixed end moment? Here MFAB will come. This is A, this is B, hence this is MFAB. This end is MFAB and this end is MFBA. Now just see with respect to AB how W will rotate. Clockwise or anti-clockwise? How W is rotating? Clockwise or anti-clockwise?
Clockwise.
What is the resisting?
Moment.
Resisting means ಈ clockwise ಬರ್ತಾ ಇದೆ ಅಂದ್ರೆ ಈ ಕಡೆಯಿಂದ ರೆಸಿಸ್ಟ್ ಮಾಡೋದು ಯಾವ ಟೈಪ್ ಆಫ್ ಮೂಮೆಂಟ್?
Anti-clockwise moment.
Anti-clockwise. This is the resisting moment. Similarly, with respect to BA, how it is rotating?
Anti-clockwise.
What is the resisting moment?
Clockwise.
Clockwise. Now I will define MF AB equals minus WL by 8. This is the equation you have to remember. Why it is minus? Why it is minus? Why it is minus? Why it is
Resisting
minus?
moment will be anti-clockwise.
Resisting moment
Resisting
will
moment
be
will be
anti-clockwise. Hence, that's why I have taken minus. Clear? Any doubts? ಏನಾದ್ರು ಡೌಟ್ ಇದೆಯಪ್ಪ ಗೊತ್ತಾಯ್ತಾ ಯಾಕೆ ಮೈನಸ್ ತಗೊಂಡೆ ಅಂತ?
Yes, sir.
Yes, here what is MF BA?
Omega L by 8.
is plus WL by 8. Why plus WL by 8?
resisting moment will be clockwise.
Resisting moment will be clockwise. Very good. See, sometimes they may sit in the MCQ question. Why it is negative? Why it is positive? These are all very basic things, but definitely students will don't know the basic concepts. That's a major problem. Okay. Now ಗೊತ್ತಾಯ್ತಾ ಯಾಕೆ ಅಲ್ಲಿ ಮೈನಸ್ ಬರೀತಾರೆ ಅಂತ ನಿಮಗೆ ಜಸ್ಟ್ ಸುಮ್ಮನೆ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ಕೊಂಡು ಹೋಗಿರ್ತೀರಾ ನೀವು ಅಲ್ವಾ? ಯಾಕೆ ಅಂತ ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು. ಯಾಕೆ ಅದು ಮೈನಸ್, ಯಾಕೆ ಅದು ಪ್ಲಸ್ ಅಂತ. Okay, clear? Any doubts? Any doubts here? Now I will take one more example. Now I will take this eccentric load. W will place at some distance A and B. The total length is L. Now how this is I take this is BC. Say BC. Now what is the here? How it will rotate towards B? Clockwise. Hence the resisting is anti-clockwise. This is MF BC. How it will rotate? Anti-clockwise. The resisting is clockwise. Therefore MF CB. Now what is MF BC? Minus W A B square by L square. What is MF CB? Plus W B A square by L square. See, these are the things you have to remember. ನೀವು ನೆನ್ಪಿಟ್ಕೊಂಡಿರ್ಬೇಕು. ಇದೆಲ್ಲ MCQ ನಲ್ಲಿ ಕೇಳ್ತಾರೆ. ಡೈರೆಕ್ಟ್ ಆಗಿ MCQ ನಲ್ಲಿ ಕೇಳ್ತಾರೆ. ಇಲ್ಲ ವ್ಯಾಲ್ಯೂಸ್ ಕೊಟ್ಬಿಟ್ಟು FEM ಮಾಡಿ ಅಂದ್ಬಿಡ್ತಾರೆ. ಓಕೆ, ಬರ್ಕೊಂಡ್ರಾ? Shall I move on to next slide? ಬರ್ಕೊಳ್ಳಿ. Next, I will take next eccentric moment. At least few important cases are ನೆನಪಿರಬೇಕು. Now UDL. I will take distributed load. Length L. Say I will take PQ. Now how it will rotate? Resisting, it will rotate clockwise. Resisting, here it will rotate anti-clockwise. Resisting is like this. This is MF PQ and this is MF QP. Word enar kodabodu A B B A whatever it may be. What is MF PQ? Any idea? What is the fixed moment?
It's
Yes, minus what?
which one? Omega L square by 12.
W L square by 12, not omega. It's a load.
W L square by 12.
WL
Sorry.
square by 12. Here similarly MF QP is
Plus W L square
by 12. Next I will take one more thing. Uniformly varying load, UVL. Yes, any idea?
It's W L square by 15 and W L square by 30.
15 and 40. Please check once. Check for UVL. uniformly varying load,
WL square by 15 and WL square by 30.
WL square by
15.
15. Where? Here we are having apex.
Sir, at apex, it is WL square by 30.
This is base. From apex, that is MF. BA is what? W
L square by 30.
L square by
30, sir.
30. 30.
Yes, sir.
Check this. And MF AB is
WL square by 20.
WL square by 20.
20.
Or check with, I will give one more thing. Please check this answer. MF AB equals minus WL square by 30 from apex. MFBA equal WL square by 20. Check which one is right. Check whether this is right or this is one is right. I'm imposing a MCQ now. Which one is right? Google it, you are getting, I know that. At least try to answer. Which one is correct? MCQ question here only. Yes, others. ಹೇಳ್ಬೇಕು ಹೌ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳ್ತೀರಿ ಜಸ್ಟ್ ಸಿಂಪಲ್ ಅಲ್ಲೇ ಅವ್ರು ಹೇಳಿದನ್ನೇ ನಾನು ಉಲ್ಟಾ ಬರ್ದಿದ್ದೀನಿ ಅದು ಯಾವ ಸರಿ ಹೇಳಿ ಅಂತ ಎಸ್ ಟ್ರೈ ಟು ಫೈಂಡ್ ದಿ ಆನ್ಸರ್ ಐ ವಿಲ್ ಗಿವ್ ಮೊಮೆಂಟ್ ನೌ clockwise L/2 L/2 take AB or BC whatever it may be. Now what is the answer for MFAB and MFBA? Next you take this. See ಇದೆಲ್ಲ ಗೊತ್ತಿರ್ಬೇಕು ನಿಮಗೆ immediately ಮಾಡಬೇಕು. M/4 what is M/4 clockwise or anti-clockwise? It is anti-clockwise. L/2 L/2 AB. What is MFAB? What is MFBA? Yes, come on. Class should be interactive. ನಿಮಗೆ ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ ಪರವಾಗಿಲ್ಲ ಹೇಳಿ ತಪ್ಪಾದ್ರೂ ತೊಂದರೆ ಇಲ್ಲ. I'm waiting. You got the answer? No, sir.
Sir, it's minus M/4 and plus M/4.
Minus
M
for
by
first
4.
one.
Yes, sir.
For first one,
Yes, sir.
minus
M/4
M/4. This one
plus M/4.
plus M/4.
Yes, sir.
Okay, let's see. Okay, for this,
It will be reverse of the first thing.
it will be
Plus
reverse.
M/4
Okay.
and minus M/4.
Check once again. I'm giving check because I will give you one statement. Moment is same throughout.
Minus and plus also.
Only M, sir.
Only
Huh? Only M.
Yes, sir.
See for this, don't confuse. For this, always from apex, you are getting 30. From base, you are getting 20. Okay. From apex, it is always 30. From base, it is 20. ಸೊ ಅವ್ರು ಏನ್ ಹೇಳಿದ್ರು ಅದು ಸರಿ ಇದೆ. ನಾನು ಸುಮ್ಮನೆ ಕನ್ಫ್ಯೂಷನ್ ಮಾಡಕ್ ಬರ್ದೆ ಏನ್ ಹೇಳ್ತಿರೋ ನೋಡೋಣ ಅಂತ. ಓಕೆ ಹಿಯರ್ ಪ್ಲೀಸ್ ಚೆಕ್. This is right, ma. For couple. Now I want for couple. See, if it is clockwise, Both end it will rotate clockwise. It will just rotate like this only. Don't confuse now. Now what is the sign? Here it is clockwise. Both the end will rotate like this only. So please check this. So I think now it should be minus m by 4. Please check this. Plus m by 4 plus m by 4. Okay, these are the loadings you must remember when you are solving problems. Okay, this is with respect to what? Fixed end moments. Any confusion in fixed end moments? I hope you are having all cases of equations with you now. Now you are having the term 2ei by L. What is ei by L? 2ei by L. What is 2ei by L? Any idea? What is the 2ei by L? What is EI? What is EI?
Flexural rigidity.
What is EI? Flexural rigidity, right? Flexural rigidity. When we are doing flexural rigidity with respect to L, that is nothing but whatever the 2ei by L. It is just like a rotational contribution of the member. It's a rigidity factor. It's a rigidity factor. Okay, how we are going to arrive? Adunu ಸ್ವಲ್ಪ ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು ಸ್ವಲ್ಪ ಯಾವ ತರ ಅಂತ. See, if AB is the member, I have taken alva. AB is the member. This is subjected to any kind of loading. Any kind of loading. So the very first step is what? Very first step is we determine FEM. We determine FEM, right? So this is MFAB and it is MFBA. So if the beam is subjected to general loading, the beam is subjected to general loading is the given problem. This is the given problem. The first step is what? The first step is FEM, that is over. Then the next step, second step is, that is rigidity factor comes into picture. Rotational contribution we have to evaluate. That rotational contribution is very, very important. If I am applying a moment, a rotation at B, and I am fixing this part for BA, I am computing for AB, right? I am computing for AB. That's why I am allowing this particular joint a moment AB, MEAB. I am allowing this particular support to, I am giving this particular support to moment. What happens? It will get deflected. Like this, it will get deflected. Now you are having this theta contribution. This is theta A and this end is theta B. See, always when you are giving moment, this particular thing, you have to remember this contribution. This contribution is 4ei theta A divided by L. The remaining end contribution is 2ei theta A divided by L. Okay, this is the thing. This is the expected thing. You have to get 4ei theta A divided by L, 2ei theta A divided by L. Similarly, now in third step, what I will do, I will fix this end. I will allow to rotate this joint. What happens? It will rotate like this. Will rotate like this. If you plot a slope, this is anti-clockwise theta B, and this is clockwise theta A. So now this will become 4ei theta B by L, and this will become 2ei theta A by L. Rotation is over. Now I will allow to sway. I will allow to sinking or sway the member. Sway the member. Now what happens? It will get this way like this. This is the sway contribution. You have to remember this thing also. This is delta is shifted because of this rotations. This is shifted to delta. Here you are getting the value as 6 EI delta by L square. Here also the same value 6 EI delta by L square. There is no changes in this delta contribution. So what are the things? This is FEM plus rotation contribution with respect to A plus rotation contribution with respect to B plus delta contribution. Now the final equation is given by MAB equals, I am writing here this one, this sum here is to sum. B again is to the sum. MAB equals MFAB plus 4EI theta A divided by L plus 2EI theta A, sorry, 2EI theta A by L, 2EI, no, you have to take for members, full members, 4EI MFAB, MFAB plus 4EI theta A by L. Now you have to come for this plus this member, full member, 2EI theta B divided by L and this particular contribution, this one, minus 6EI delta by L square. Now if you simplify, MAB equals MFAB plus, here if you take 2EI by L common factor, 2EI by L common factor, what is here remaining? 2 theta A plus here what it remains? Plus theta B only it will remain. You have taken 2EI by L outside, right? What is the remaining thing? 3 delta by L. See, this is the slope deflection equation. This is the slope deflection equation. Similarly for MBA equals this one, MFBA plus BA member. This is BA member. This is AB member. For BA, 2EI theta A divided by L plus 4EI theta B by L here minus anti-clockwise 6EI delta divided by L square. Finally, what you are getting? MBA equals MFBA. You take plus 2EI by L outside. What is remaining? 2 theta B plus theta A minus 3 delta by L. See, this is the final equation for BA. Now, in MCQ, see, this is in technical terms, this is called whatever the rotatory end, this is foreign. This is foreign. For AB, BA is foreign. Now I can sit a question like, what is the rotation contribution for foreign if the beam AB is subjected to loading? What is the answer? What is the rotatory contribution of foreign when the beam is subjected to loading? This is the beam is subjected to loading. Rotatory contribution from foreign. For this member, this is foreign. For this member, this is foreign. So what is the answer? What is the answer? What is the rotatory contribution for the member of foreign subjected to loading? That is 2EI theta A by L or 2EI theta by L. What is the rotation contribution at moment applied end? 4EI theta by L. So this is the thing. Generally, they will give figures sometimes. You have to match the following. You have to match the perfect things. when they are applying moment on that point 4ei by L. See here you are applying moment, rotation. That's why 4ei theta by L. Here is applying the moment. That's why 4ei theta by L. Further end 2ei theta by L. So this is very important slide. This is very important with respect to slope deflection equation. With respect to slope deflection equation. Any doubts here? Any doubts? ಇಷ್ಟು ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ ಅಷ್ಟೇ. ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ ಅಂದ್ರೆ ನೀವು ಫೈನಲ್ ಈಕ್ವೇಶನ್ ಕಲ್ತ್ಬಿಡಿ. ಫೈನಲ್ ಈಕ್ವೇಶನ್ ಯಾವ ತರ ಮಾಡ್ತಾರೆ, ಇಷ್ಟು ಪ್ರಾಸೆಸ್ ಬರುತ್ತೆ. ಒಂದು FEM, ಇನ್ನೊಂದು ರೊಟೇಟರಿ ಕಾಂಟ್ರಿಬ್ಯೂಷನ್, ಇನ್ನೊಂದು ಸ್ವೇ ಕಾಂಟ್ರಿಬ್ಯೂಷನ್. ಇದು ಮೂರನ್ನು ಆಡ್ ಮಾಡ್ತಾರೆ. Okay, shall I move on to next step? Okay. Now, what are the steps in what is slope deflection method? Why it is important? Sometimes they may ask like compute relative stiffness, compute what is the rotation contribution of the member. Like that they will ask sometimes for MCQ questions. That's why you must know how to solve the entire problem steps. Steps you must know. Okay. Steps first we will go for slope deflection method. That's why taking steps involved in slope deflection method. What is the first step? What is the first step? You know the equation MAB equals MFAB plus 2EI by L 2 theta A plus theta B minus 3 delta by L. Now tell me, what is the first step? What is the step 1? Identify the kinematic indeterminates or unknowns to be determined. Or unknowns. I will give an example. I will give this beam for analyzing. Now, what is the kinematic intensity of the given beam? What is the kinematic intensity of the given beam?
3J minus R.
No. You have to see kinematic indeterminacy at each joint displacements. Here, how many reaction? 3. Therefore, what is the joint displacement? 0. Because of this fixity. This is 0, this is 0. This is theta B. Here, because of this vertical, this is 0. Because of this fixity, it is 0. See, please keep in your mind, in slope deflection method or in moment distribution, whatever the displacement method, the only possible unknowns are only rotations. Only rotations ಬರ್ತಾ. ಈ sway ಆದ್ರೆ ಸಿಂಕ್ ಆದ್ರೆ ಸಪರೇಟ್ ಆಗಿ ತಗೊಳ್ತೀವಿ. ಅದು ಬಿಟ್ರೆ ಜಾಯಿಂಟ್ ಅಲ್ಲಿ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಓನ್ಲಿ ರೊಟೇಷನ್. ಅದನ್ನು ಸಹ ನಿಮ್ಮ MCQ ಕ್ವಶನ್ ಅಲ್ಲಿ ಕೇಳಬಹುದು. ಇನ್ ಸ್ಲೋಪ್ ಡಿಫ್ಲೆಕ್ಷನ್ ಮೆಥಡ್ allowed kinematic indeterminacy are only rotations, both rotations and translations, only translations, or none of the above, or all of the above. On that case, you have to mark that in any kind of displacement method at each joint, there is only the possible thing is rotations. So now what are the unknowns with respect to given problem? Theta B and theta C. These are the rotations. See your equations. I'm talking about rotation only. Here delta is sinking. If in a MCQ, if he is giving that rotation and sinking, rotation and sway, you have to mark that thing. Rotation and sinking in case of beams, rotation and sway in case of frames. in case of frames. So any doubts in first step? Any doubts in first step? To identify the kinematic indeterminants. So I have given one session also. In previous session, we discussed a lot of things with respect to degree of freedom and kinematic indeterminacy. Degree of freedom must be degree of freedom in Barala. Eradu method allo degree of freedom Barala. Bharat Bari kinematic indeterminacy. Any doubts? Okay. I will give one more problem. Please identify what is the kinematic indeterminacy to determine first step. For this beam, what is the kinematic indeterminacy?
Theta B, theta C, theta.
See, I will give like A, B, C, D, A, B, C, D. What is kinematic indeterminacy?
Theta B, theta C, theta D.
theta D.
Good. Aste. And also you are getting only maximum 2 aste MCQ nalella illa 1 aste avaru kododu. So the kinematic indeterminacy is theta B, theta C, theta D. 3. Andre ade unknowns. So ultimate aim of the problem is to determine those unknowns and substitute in this equation. You are getting final moment. ಅಲ್ವನ್ರಿ ನಿಮ್ಗೆ MFAB ಎಲ್ಲ ಗೊತ್ತಲ್ವಾ? MFAB, MFBA ಎಲ್ಲ ಗೊತ್ತು. UDL ಪಾಯಿಂಟ್ ನೋಡು ಈಕ್ವೇಶನ್ಸ್ ಗೊತ್ತು. ಹಾಕೊಳ್ತೀರಾ. EA ಎಲ್ಲ ಗೊತ್ತಿರುತ್ತೆ. ಥೀಟಾ ಇದೇ ಅನ್ನೋನು ಇದು ಬಂದ್ಬಿಟ್ರೆ ಇದನ್ನ ತಗೊಂಬಂದು ಇದಕ್ಕೆ ಹಾಕಿದ್ರೆ ಫೈನಲ್ ಮೂಮೆಂಟ್ ಸಿಗುತ್ತೆ ಅಷ್ಟೇ ಪ್ರಾಬ್ಲಮ್. So now I will give one more problem. Identify what is kinematic indeterminacy because ಇದು ಬಂದ್ರೇನೆ ನಿಮ್ಗೆ ಎರಡು ಮೆಥಡ್ ಮಾಡಕ್ ಆಗೋದು. ಇಲ್ಲ ಅಂದ್ರೆ ಬರಲ್ಲ ನಿಮ್ಗೆ. Yes. What is kinematic indeterminacy?
Q and R, theta Q and theta R.
That's all. Theta Q and theta R. That's it. Now, for this,
Theta A, theta B, theta C.
theta A, theta B, theta C ಅಷ್ಟೇ ಆಯ್ತಾ. ಇಲ್ಲಿ ಫಿಕ್ಸಿಟಿ ಇಲ್ಲ ಸರ್, ಡೆಲ್ಟಾ ಬಂದ್ಬಿಡುತ್ತೆ, ಬರಲ್ಲ. ಬರೀ theta A, theta B, theta C ಅಷ್ಟೇ. ಗೊತ್ತಾಯ್ತಾ? Any doubts? Any doubts in kinematic indeterminacy? Any doubts in kinematic indeterminacy? Shall I move on to next step?
Yes, sir.
Okay. Step 2.
Okay, class.
See, when we are doing at fixed joints, one please remember at fixed end, rotation is always 0. Here, theta A is theta A is 0. ಅಲ್ವಾ? ಇದನ್ನು ಕೇಳಬಹುದು ನಿಮಗೆ MCQ ನಲ್ಲಿ. At fixed end always rotation is 0. There is no theta. ಇದನ್ನು ಮೈಂಡ್ ಅಲ್ಲಿ ಇಟ್ಕೊಂಡಿರಿ, ಇದನ್ನು ಒಂದ್ ಕಡೆ ನೋಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. The rotation contribution of fixed end is always 0. Okay. Next, slope deflection equation. Now I will give a simple thing. Here I will give UDL of 2 kilonewton per meter subjected to 4 meter I, and I will give 2I, and I will take a point load of 4 kilonewton at 2 meter, 2 meter. Okay. Now slope deflection equation. What is slope deflection equation? Here I have written slope deflection equation. MAB equals, well before going to this right, FEM. It's very good. Now you will take FEM, fixed end moment. Fixed end moments. In fixed end moments, first AB member I am assuming to be fixed. This is 2 kilonewton and 4 meter. These are the possible moment. What is MFAB? What is the equation? MFAB. How much you are getting? What is MFBA? How much you are getting? 2 into 4 square by 12, 32 by 12. How much? .6 kilonewton meter, and this is ನಿಮ್ಗೆ MCQ ನಲ್ಲಿ ಬರೀ ಒಂದು ಬೀಮ್ ಕೊಟ್ಬಿಟ್ಟು ಒಂದು ಹಾಕ್ಬಿಟ್ಟು ವಾಟ್ ಇಸ್ ದ FEM ಫಾರ್ ABBC ಎರಡು ವ್ಯಾಲ್ಯೂ ಕೊಡ್ಬೋದು ಅವರು. ಅವಾಗ ನೀವು ಮೈನಸ್ ಪ್ಲಸ್ ಇದೆಲ್ಲ ವೆರಿ ಕೇರ್ಫುಲ್. ನೌ ಐ ಆಮ್ ಟೇಕಿಂಗ್ ಎ ಪಾಯಿಂಟ್ ಲೋಡ್. ಐ ಹೋಪ್ ಆಲ್ ಆರ್ ಸ್ಲೀಪಿಂಗ್. ಆನ್ಸರ್ ಮಾಡಬೇಕು. 2 meter 2 meter anti-clockwise. What is MFBC?
WL by
WL by
8.
8. So minus 4 into 4 by 8. 16 by 8 minus 2. MFCB. WL by 8. So also plus 2. So this is FEM. Any doubts in FEM? ಸೊ ಈ ತರ ನಿಮ್ಗೆ ಏನೇ ಎನಿ ಕೈಂಡ್ ಆಫ್ ಲೋಡ್ ಕೊಡ್ಬೋದು. ಅವಾಗ ನಿಮ್ಗೆ ಇಲ್ಲಿ ಮಾಡಿದೀವಲ್ಲ ಇದನ್ನ ನೀವು ಕರೆಕ್ಟ್ ಪ್ರಾಪರ್ ಆಗಿ ಯೂಸ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ FEM ನ ಈ ಸ್ಟೆಪ್ ನ. ಓಕೆ, ಸೊ ಎನಿ ಡೌಟ್ಸ್ ಇನ್ FEM? ಎನಿ ಡೌಟ್ಸ್ ಇನ್ ಫಸ್ಟ್ 2 steps?
No, sir.
Okay, thank you. FEM is over. Next step 3. Use slope deflection equation. See, this is also called slope. Slope means theta. Deflection means delta. That is slope deflection. Theta delta equation, slope deflection equation andre adakke nodi equation alli theta irutte delta irutte. Slope deflection equation. MAB equals MFAB. MFAB is minus 2.6 plus 2 into EI. EI is same. EI is EI only. 2 EI by L. L is 4 into 2 theta A plus theta B minus 3 delta by L. See, here in this problem I have not given any sinking. If the sinking is not given, this will become 0 because sinking is not given. Here theta A is also 0. Why theta A is 0? Why theta A is 0? Because support A is fixed. This is the thing. That's why 0. What is the remaining thing? Minus 2.6 plus 2 by 4 will become 0.5 EI theta B. Take as equation number 1. Similarly, if you do, you are getting BA equation 2, BC equation 3, CB equation 4. Any doubts? Any doubts in second step? Next, please try to do BA. What is MBA? Then just answer ready. Equations ready.
Sir, ಇನ್ನೊಮ್ಮೆ ಹೇಳಿ sir.
ಇನ್ನೊಮ್ಮೆ ಹೇಳ್ಬೇಕನೋ?
Sir, ಅದು ಲಾಸ್ಟ್ equation sir.
ಇದು ಈಕ್ವೇಶನ್ಸ್ ಗೊತ್ತಾಯ್ತಲ್ವಾ? ಈ ಈಕ್ವೇಶನ್ ಗೆ ಹಾಕಿದೀನಿ. ವಾಟ್ ಈಸ್ MAB? MAB equal MFAB. MFAB value is 2.6 minus 2.6 plus 2EI by L. 2EI by EIA ಇದೆ, so EIA ತಗೊಂಡೆ. 2 ಇದಿದ್ರೆ 2 into 2 4 EI ತಗೊಳ್ತಾ ಇದ್ದೆ. 2EI by L is 4, so I have taken same 2EI by 4 into 2 theta A plus theta B minus 3 delta by L. But theta A is 0. Why it is 0? Because fixed. This is fixed. And delta is also 0 because sinking is not given in the problem. If I am giving that support B sinks by 2 mm, then you must take the 2 mm in delta. But in this case, I have given there is no sinking. Hence it is also 0. Now finally you are getting this equation. You take this equation as equation 1. Now please determine what is theta MBA. What is MBA? What is equation 2? Similarly determine what is MBC and MCB. What is MBA? Plus 2.6
plus EI theta B.
EI theta B. Ashte alva? So take that as equation number 2. Similarly, what is MBC? MFBC, that is minus 2 plus 2 EI by L. 2 into 2, 4. 4 by 4 EI. EI into 2 theta B plus theta C. So finally you are getting minus 2 finally you are getting minus 2 plus 2 EI theta B plus EI theta C. Sari idya? This is equation 3. Right? Please check equation 3. Is it fine? 2 EI by L. 2 into 2, 4 EI. By L is 4. 4 get cancels. Next. Similarly, determine MCB. MCB, you are getting illest straight up 2 plus EI theta B plus 2 EI theta C. This is equation number 4. You are getting 4 equations. You are getting 4 equations. You are getting 4 equations. So any doubts in 4 equations? Any doubts in step number 3? One simple problem ಮಾಡ್ಕೊಳ್ರಿ. ನಿಮಗೆ ಡೈರೆಕ್ಟ್ ನಾನು MCQ ಹೋಗ್ಬಿಟ್ಟಲ್ಲ, ನಾನು ಎಲ್ಲೋ ಯಾವುದೋ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಹೇಳ್ತಾ ಇದ್ರೆ ನೀವು ಎಲ್ಲೋ ತೇಲಾಡ್ತಿರ್ತೀರಾ, ನಿಮ್ಗೆ ಆನ್ಸರೇ ಗೊತ್ತಾಗಲ್ಲ. ಸೊ ಒಂದ್ ಪ್ರಾಬ್ಲಮ್ ಸರಿಯಾಗಿ ಕಲ್ತ್ಕೊಡಿ. ಒಂದೇ ಒಂದ್ ಪ್ರಾಬ್ಲಮ್ ಸಾಕು, ಎಂಟೈರ್ MCQ ಸಾಲ್ವ್ ಮಾಡ್ಬೋದು. ಆಯ್ತಾ? ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ ಹೋಗಿ ನೀವು ಹೇಳ್ಬೇಕು, ಸರ್ ಆಯ್ತು ಮುಂದಕ್ಕೆ ಹೋಗಿ ಅಂತ. ಮಾಡ್ತಾ ಇದ್ರೆ ಬರಲ್ಲ. ಆಮೇಲೆ ರೆಕಾರ್ಡಿಂಗ್ ನೋಡ್ ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ ಟೈಮ್ ವೇಸ್ಟ್ ಮಾಡ್ಕೋಬೇಡಿ. ಪ್ಲೀಸ್ ಇಂಟರಾಕ್ಟ್ ಇನ್ ಕ್ಲಾಸ್. ಆಯ್ತಾ? 4 equation. Any doubt in step number 3?
Yes, sir.
Clear? Next step is very very important. ಅದಕ್ಕೆ ಆಯ್ತಾ? ಇಲ್ಲಿವರೆಗೂ ಏನಾದ್ರು ಡೌಟ್ ಇದೆಯಾ 3 equations ಅಲ್ಲಿ?
No, sir.
ಓಕೆ. ಇಲ್ಲಿ ನೀವು ಏನೇನ್ ಪಾಯಿಂಟ್ಸ್ ನ ತಲೆ ಇಟ್ಕೋಬೇಕು? ಒಂದು ಫಸ್ಟ್ ಪಾಯಿಂಟ್ ಇಸ್ ಹೌ ಟು ಫೈಂಡ್ ಕೈನಮ್ಯಾಟಿಕ್ ಇಂಡಿಟರ್ಮಿನೆಸಿ. ಅದ್ರ ಮೇಲೆ MCQ ಬರ್ಬೋದು. ಹೌ ಟು ಫೈಂಡ್ ಫಿಕ್ಸ್ಡ್ ಎಂಡ್ ಮೊಮೆಂಟ್, ಅದ್ರ ಮೇಲೆ MCQ ಬರ್ಬೋದು. ಹೌ ಟು ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಸ್ಲೋಪ್ ಡಿಫ್ಲೆಕ್ಷನ್ ಇಕ್ವೇಶನ್ ಅಲ್ಲಿ MCQ ಇದಕ್ಕೆ ಬರಲ್ಲ. ಇದ್ರಲ್ಲಿ ಏನ್ ಕೇಳ್ಬೋದು? ಫಿಕ್ಸ್ಡ್ ಎಂಡ್ ಥೀಟಾ ರೊಟೇಷನ್ ಇರತ್ತಾ? ಸಿಂಪ್ಲಿ ಸಪೋರ್ಟೆಡ್ ಎಂಡ್ ಅಲ್ಲಿ ಇದ್ರೆ ಇರತ್ತಾ? ಹಿಂಜ್ ಇದ್ರೆ ಇರತ್ತಾ? ಆತರ ಕೇಳ್ಬೋದು. ಫಿಕ್ಸ್ಡ್ ಎಂಡ್ ಇದ್ರೆ ರೊಟೇಷನ್ ಇಸ್ 0. ಸಿಂಪ್ಲಿ ಸಪೋರ್ಟೆಡ್ ಹಿಂಜ್ ಇವೆಲ್ಲ ಇದ್ರೆ ಇರುತ್ತೆ. ಥೀಟಾ ಇಸ್ ಪ್ರೆಸೆಂಟ್, ರೊಟೇಷನ್ ಇಸ್ ಪ್ರೆಸೆಂಟ್. ಆತರ ಕೇಳ್ಬೋದು. ಎನಿ ಡೌಟ್ಸ್? ಓಕೆ. ನೆಕ್ಸ್ಟ್ ವಿ ಮೂವ್ ಆನ್ ಟು 4th step. This is very very important step. Step 4. ಇದ್ರ ಮೇಲೆ ಒಂದು MCQ ಕ್ವಶನ್ ಪಕ್ಕಾ ಇರುತ್ತೆ. ಜಾಯಿಂಟ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಕಂಡೀಷನ್. Yes, what is meant by joint equilibrium condition? See, the given beam is like this. I am talking about joint, so nothing to worry about loading. Loading may be however it may be, nothing to worry, nothing to deal with loads. Here, the name itself indicates joint equilibrium. Equilibrium. So what is meant by equilibrium? What is meant by equilibrium?
3 equations.
Equilibrium, general definition. What is equilibrium?
Three equations.
Three equations,
Balance.
right? Three equations are right. What are those equations?
Effects, horizontal, vertical, and moment. Zero.
Okay, but ಆ equation zero ಅಂತ ಹೇಳ್ತೀರಾ ಅಲ್ವಾ? ಹಂಗಂದ್ರೆ ಏನು? See, equilibrium, the name itself indicates if you take specifically this joint, if you take specifically, someone put a message that balanced, right? It's a balanced, right? Very good. See, if you consider this joint, it should be balanced, which means it should be under equilibrium, means the summation of this member, moment should be zero. Equilibrium. See, when this, but you are going to consider this particular joint. If you are going to consider this particular joint, this is which kind of joint? This is which kind of support?
Fixed.
Fixed. So it's already in equilibrium.
Yes, sir.
Why it's already in equilibrium? Why it is already in equilibrium? It will not allow any kind of deformations. It is having three reactions. ನಿಮಗೆ ಇದರಲ್ಲೂ MCQ ಸೆಟ್ ಮಾಡ್ತಾನೆ. Which joint is in equilibrium condition? Fixed, roller, hinge, all the above. Fixity is already in equilibrium. Therefore, in fixed joint, you are not having any equilibrium equations. Any doubts in this particular point? Any doubts in this particular point? Fixed support is not having any kind of equilibrium equations. Why? Because the particular support is already in balanced condition. It is having three support external conditions. That three support will not allow to move any kind of translations as well as rotations at particular joint. Any doubts? So here you are not getting any kind of joint equilibrium condition. Why? Because it's already in equilibrium. So it will not allow any kind of rotations because it will develop three reactions. Okay, now if you come to B and C, at joint B, equilibrium condition is MBA plus MBC must be equal to 0. At joint C, what is joint C? How many members at joint C? How many members are meeting at joint C? How many members are meeting at joint B? Joint B, two members. Only one member. That is MCB equals 0. Now, how many joint equilibrium equations are you getting?
2.
Now tell me, I will give one more example. Here, how many joint equilibrium equations?
1.
That's all. This is the MCQ you may expect. ನಾನು ಡೈರೆಕ್ಟ್ ಆಗಿ ಅಲ್ಲಿಗೆ ಹೋಗ್ಬಿಟ್ರೆ ನೀವು ಮುಗಿತು ಔಟ್. Okay, now tell me here, how many joint equilibrium conditions? Overhead.
2.
How many joint equilibrium conditions?
3, sir.
3. Others?
2, 4.
Here, please, this very, very important thing. Generally, they will ask in MCQ. The thing is, here, BA, if you take A, B, C, D. Here, what is the equations? MBA plus MBC. Here, MCB, MCD. See, here you are getting only 2 equilibrium equations. I will give one more example for this case. If in case I am giving the value of 2 kilonewton per meter in overhang of 4 meter, what you have to do, that is very, very important thing. The thing is, you just observe over here. Observe here. If you take moment to this point, what is the moment? What is the moment at C for this overhang? What is the moment? How much it will develop a moment at point C?
16.
This
8
overhang.
kilometer meter. 8 kilometer meter.
2 into 4, 8. 2 into 4, 8. Acts at 4 by 2, which means
16.
16. Sorry.
yes, yes. Don't make a mistake. It's a very tumba chick mistake madbedi. Okay, 16. In which direction? Clockwise or anti-clockwise?
Clockwise.
What is the resisting moment?
Anti-clockwise.
Clockwise.
Anti-clockwise, 16 kilonewton meter. Now you just observe here. The joint equilibrium condition for this structure is at joint B, MBA plus MBC equals 0. At joint C, this is very, very important. You may get in MCQ. MCB minus 16 equal to 0. See, at joint C, here it's already you have converted into moment.
Yes, sir.
Here, overhang portion you don't consider in slope deflection. We won't consider that particular thing in slope deflection equation. We are considering this particular thing in where? In joint equilibrium equations. In joint equilibrium condition, please take a note. In case of overhang, we are considering that overhang contribution in joint equilibrium conditions. Not we are going to consider in slope deflection equation. ನೀವು ಪ್ರೀವಿಯಸ್ ಪ್ರಾಬ್ಲಮ್ ಮಾಡಿದ್ರಲ್ಲ, ಇಲ್ಲಿ ನೀವು MCD MDC ಅಂತ ಮಾಡಲ್ಲ. ಅರ್ಥ ಆಯ್ತಾ? ನಾನು ಏನ್ ಹೇಳಿದೆ, ಈ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಓವರ್ ಹ್ಯಾಂಗ್ ಕೊಟ್ರೆ MCD MDC ಅಂತ ಮಾಡಲ್ಲ. ಅದನ್ನ ಮೊಮೆಂಟ್ ತಗೊಂಡು ಜಾಯಿಂಟ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಕಂಡೀಷನ್ ಹಾಕ್ತೀರಾ. Doubts? Now tell me, what is the total number of equation? 2 only. Any doubts? I think ರಚನಾ ನಮ್ಮ ಮಾತಾಡ್ತಿರೋದು. ಏನಮ್ಮ ಹೆಸರು?
Shambhavi, sir.
Okay. Any doubts?
No, sir.
Okay.
Got it, sir.
Okay. Others? ಇನ್ನೊಬ್ಬ ಯಾರೋ ನಿನ್ನ ಹೆಸರೇನೋ ತುಂಬಾ ಇಂಟರಾಕ್ಟ್ ಮಾಡ್ತೀಯಲ್ಲ? ಚಿದಾನಂದ್. ಹಾ, ಎನಿ ಡೌಟ್ಸ್ ಚಿದಾನಂದ್?
No, sir.
ಇಲ್ಲ. ಅದರ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ಇನ್ನೊಬ್ಬ ಯಾರು ನಂಗೆ ಮೆಸೇಜ್ ಕಳಿಸ್ತಾನೆ, he is also doing some, at least ನಿಮ್ಮ ಮಾತಾಡಕ್ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ಚಾಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಹಾಕ್ಬೋದು. ಎಸ್, ನವೀನ್, ಎನಿ ಡೌಟ್ಸ್? ರಾಹುಲ್, ಎನಿ ಡೌಟ್ಸ್? Rahul is also doing very good. Naveen is very good. Okay, ಎಲ್ಲರೂ ಮಾಡಬೇಕು. Okay, clear? Yes, now I will give one small thing. You just I will ask like ಕೆಲವು ಟೈಮ್ ಏನ್ ಮಾಡ್ತಾರೆ MCQ ನಲ್ಲಿ ಜಾಯಿಂಟ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಕಂಡೀಷನ್ ಈಗ ನಿಮ್ಗೆ ಹಾಕನಲ್ಲ ಪ್ರಾಬ್ಲಮ್, ಆ ತರ ಹಾಕ್ಬಿಟ್ಟು 4-5 ಆಪ್ಷನ್ಸ್ ಕೊಡ್ತಾರೆ. ನಿಮ್ಗೆ ಯಾವ ತರ ಬೇಕಾದ್ರೂ ಕೇಳ್ಬೋದು. ಈ ಸ್ಲೋಪ್ ಡಿಫ್ಲೆಕ್ಷನ್, ಮೊಮೆಂಟ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಅಂದ್ರೆ ನೀವು ಫುಲ್ ಮೆಥಡ್ ಮಾಡಕ್ ಬರ್ಬೇಕು ನಿಮ್ಗೆ. ನೀವು ಸುಮ್ಮನೆ MCQ ಹಿಡ್ಕೊಂಡು ಹೋದ್ರೆ ಏನು, ನಾನು ಹೇಳ್ತಾ ಇದ್ರೆ ನಾನು ಸುಮ್ಮನೆ ಆಪ್ಷನ್ ಟಿಕ್ ಹಾಕೊಂಡು ಹೋಗ್ತೀರಾ ಅಷ್ಟೇ. ಆಮೇಲೆ ಓಕೆ, ನೌ ಟೆಲ್ ಮೀ, ಐ ವಿಲ್ ಗಿವ್ ಲೈಕ್ ದಿಸ್. ಓಕೆ, ಇಟ್ಸ್ ವೆರಿ ಗುಡ್. ನೋ, ಐ ವಿಲ್ ಗಿವ್ ದಿಸ್ ಟೈಪ್ overhang, here also overhang. No. Okay, 2 kilonewton per meter, 2 meter, 2 kilonewton, 1 meter. So this is not required. A, B, C, D. What is the joint equilibrium condition? ನಾನು 4 ಆಪ್ಷನ್ ಕೊಡ್ತೀನಿ, ಯಾವ್ದು ಸರಿ ಅಂತ ನೀವು ಹೇಳಬೇಕು.
Okay, sir.
Okay, what is the joint equilibrium condition? What is the joint equilibrium condition? Condition at B and C. ಎರಡೂ. I will give 4 options. will give code. Which one is correct? 1 only, 1 and 2, 2 and 3, 1 and 4.
It's one only, sir.
1 only.
Sir, 2 and 3, sir.
2 and 3.
Yes, sir.
See, ನಿಮ್ಮ ಜೊತೆಗೇನೆ ನಾನೇ ಇಲ್ಲಿ ಸುಮ್ಮನೆ ಬರ್ದಿರೋದು MCQ ನ. Try others. Any answers?
Sorry, sir, 1 only.
Sir,
One
1
only.
and 3 ಬರುತ್ತೆ sir.
1 and 3. See, I have got 3 different answers. Right?
1 and 3.
1 and 3.
1 and
But-
3, sir.
But optional 1 only ಅಂತ ಹಾಕ್ಬೋದು sir.
Option 1 only ಅಂತ ಹಾಕ್ಬೋದು, right? See, we will see. At
One
joint B, see ಅದಕ್ಕೆ ಹೇಳಿದ್ದು ನೋಡಿ, ಯಾಕೆ ನಿಮ್ಗೆ ಕಟ್ ಆಫ್ ಎಲ್ಲ ಕಡಿಮೆ ಇರುತ್ತೆ ಅಂದ್ರೆ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ನಲ್ಲಿ ಒಂದು ಸ್ವಲ್ಪ ಡೆಪ್ತ್ ಗೆ ಚೂರ್ ಅಲ್ಲೇ ನಿಮ್ಗೆ ಕೊಟ್ಬಿಟ್ರೆ ಹೋಯ್ತು, ಎಲ್ಲರೂ ನೆಗೆಟಿವ್ ಮಾರ್ಕಿಂಗ್ ಬಿದ್ಬಿಡ್ತೀರಾ. ಸೊ ಅದಕ್ಕೆ ಬಿ ಕೇರ್ಫುಲ್. ಕಾನ್ಸೆಪ್ಟ್ ತಿಳ್ಕೊಳ್ಳಿ. MCQ ಏನ್ ಆರಾಮ ಮಾಡ್ತೀರಾ ಕಾನ್ಸೆಪ್ಟ್ ಗೊತ್ತಿದೆ. ಜಾಯಿಂಟ್ ಬಿ ಬಂದಾಗ ಈಗ ಮತ್ತೆ ನೀವು ಹಿಂಗ್ ಬರ್ಕೊಳಿಬೇಕು. ಹಿಂಗ್ ಬರ್ಕೊಳ್ಳಿ. ಇಲ್ಲಿ ಏನಿದೆ, ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಅಲ್ವಾ, ರೊಟೇಟಿಂಗು. 2 2s are 4, 4 into 1, but it will create resisting moment. This is anti-clockwise, resisting is clockwise, so it will become 4. And here B alva, so clockwise 4 plus BC equals 0. Any options are there? First option, right? Now you come to joint C, so it is clockwise, resisting is 2, so you are having -2 plus CB equals 0. Any options are there?
No, sir.
-2 plus CB.
Sir,
Oh,
3.
here is there, but here I have not given 1 and 3. I have not given 1 and 3, right? So
Yes, sir.
1 only. You have to go for 1 only. Or in some cases, what they will do, they will give none of the above. On that case, what you will do? You are going to 1 or 4?
None of the above sir.
None of the
None of the above. Why? Because I'm
One-
asking for
another
both
one.
B and C. On that case, you must go for none of the above. Don't go for 1. If I have given some answer that is wrong, then 1 only is right.
Yes, sir.
Any doubts? Any doubts? This is very, very important step, joint equilibrium condition. Any doubts? Okay. Next thing. For this particular problem, what is the joint equilibrium condition? For this particular problem, the joint equilibrium condition is MBA plus MBC equals 0. MBA, MBC, you know in previous equation, right? Substitute the value. So joint A, there is no joint equilibrium condition. Joint B. What is MBA? What is MBA? 2.6 plus EI theta B. What is MBC? What is MBC? -2 plus equals 0. First write EI theta B, EI theta B. It will become 3 EI theta B plus EI theta C, which is equals to how much? 2.6 minus 2 minus 0.6. We take this as equation number 1 or A. Next, you go for joint B. Joint C. What is joint C? MCB equals 0. What is MCB value? EI theta B. EI theta B plus 2 EI theta C, which is equals to minus 2. Minus 2. If you take plus 2 on this side, it will become minus 2. Now solve equation 1 and 2 using calculators. Use calculators, solve 1 and 2. Solve equation 1 and equation 2 using calculators. What is the value of theta B and what is the value of theta C? Use calculator and solve the equation. Theta B ಇದು ನೋಡಿ 3 ಹಾಕಿ 1 ಹಾಕಿ 1 ಹಾಕಿ 2 ಹಾಕಿ ಇನ್ನು ಹಾಕಿ ನಿಮಗೆ theta B ಫಸ್ಟ್ ಸಿಗುತ್ತೆ ಆಮೇಲೆ theta C ಸಿಗುತ್ತೆ. What is the answer? Yes, what is the answer?
Sir, 0.16.
0.16 divided by EI. Next, another one.
Minus 1.08.
Minus 1.08 divided by EI. Now you got these two things. Now you know that is next step. Step 5, final moments. Final moments. Final moments. Substitute the values of theta B and theta C in step number 3. That is equation 1 to 4. Now tell me what is MAB? Substitute Madi. What is MBA? What is MBC? And what is MCB? Here you are having equation, right? MAB minus 2.6, 0.5 EI, theta B. Theta B value is 0.16 divided by EI. You substitute and tell me the final answers. To check, it must be 0 because I will tell afterwards. It must be 0, MCB. Yes, what is MAB? What is MBA? What is MBC? Tell me the final answers. Substitute both two values in this equation 4, step number 3. You are getting final answers.
Sir, innome sir.
Substitute the values whatever you are getting in step number 3. ಇಲ್ಲಿ ಇದೆಯಲ್ಲಪ್ಪ equation MAB equal 0.258 theta B. Theta B ಗೊತ್ತು ನಿಂಗೆ ಹಾಕೋ, ನಿಂಗೆ ಒಂದು ವ್ಯಾಲ್ಯೂ ಸಿಗುತ್ತೆ. EIA ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. equation 2 ಬಾ 2.6 EI theta B ಗೊತ್ತು ಹಾಕು, EIA ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, ಈ ಫೈನಲ್ ವ್ಯಾಲ್ಯೂ ಸಿಗುತ್ತೆ. equation 3 ಬಾ theta B ವ್ಯಾಲ್ಯೂ theta C ವ್ಯಾಲ್ಯೂ ಎರಡು ಗೊತ್ತು, ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋ, EIA ಎರಡರಲ್ಲೂ ಇದೆ, ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, ಒಂದು ವ್ಯಾಲ್ಯೂ ಸಿಗುತ್ತೆ. ಅದೇ ತರ CB ಮಾಡು, ಆ ಫೈನಲ್ ಆನ್ಸರ್ ನ ಹೇಳು ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. What are the answers? What is MAB? Calci ತಗೊಳ್ರಿ, minus 2.6 plus 0.5 multiplied by 0.16. Have you got 2.06 kilonewton meter? Please check 2.68 kilonewton meter. It must be minus 2.68 because to satisfy joint equilibrium condition. Check the final answers.
ಸರ್ 2.52 ಬರ್ತಿದೆ ಒಂದೇದು ಸರ್ 52
ಯಾವ್ದಪ್ಪ ಫಸ್ಟ್ ಒನ್ ಸೆಕೆಂಡ್ ಒನ್
ಫಸ್ಟ್ ಒನ್ ಸರ್ MBB
2.52 na okay 2.52 next please check the answers check this is also I think 2.7 or some other value it's okay
2.7.
nearby value nothing to worry
2.76
2.76
76
then it must be minus 2.76 please check because to satisfy joint equilibrium condition must be 0 alwa ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ ಲಾಸ್ಟ್ ಸ್ಟೆಪ್ BMD ಅದನ್ನ ನಿಮಗೆ ಬರೀ BMD ಕೇಳ್ತಾನೆ ಅದನ್ನ ಹೇಳ್ಕೊಟ್ಬಿಡ್ತೀನಿ ಹೆಂಗೆ ಅಂತ ಅಲ್ಲಿಗೆ MCQ ನಲ್ಲಿ ಬರೀ BMD ಕೇಳ್ಬೋದು ನಿಮ್ಗೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಹಾಕ್ಬಹುದು BMD ನ
ಸರ್ -2.6 MB
ಓಕೆ ಮತ್ತೆ ಅದೆರಡು ಸೇಮ್ ಬರುತ್ತೆ ನೋಡಿ ಸ್ವಲ್ಪ ಚೆಕ್ ಮಾಡಿ ಫ್ರಾಕ್ಷನಲ್ ವೇರಿಯೇಷನ್ ಓಕೆ ಇದು 0 ಬರುತ್ತಾ ಚೆಕ್ ಮಾಡಿ ಇದು 0 ಬರಲೇಬೇಕು ಸಿ ನಿಮ್ಗೆ ಏನೇ ಒಂದು ತಲೆಯಲ್ಲಿ ಇಟ್ಕೊಡಿ if in a simply supported beam ಈ ತರ ಕೇಳಿದ್ರೆ if the end support is simple support or hinge or roller the moment should be 0 if the end support ಈ ಪಾಯಿಂಟ್ ನೋಟ್ ಮಾಡ್ಕೊಳ್ಳಿ if the end support this is very important if the end support ಇದನ್ನ ನಿಮಗೆ MCQ ನಾಗ ಹಾಕ್ಬೋದು support is roller or simple support or knife edge support or hinge the moment is 0
ಸರ್ MCB 0 ಬಂತು ಸರ್
ಬರಲೇಬೇಕು ಬಂದೇ ಬರುತ್ತೆ ಅದ್ 0 ಅಂತಲ್ಲ ಅದ್ ಕಾಮನ್ ಸೆನ್ಸ್ ತಲೆ ಇಟ್ಕೊಂಬಿಡಿ ಅದ್ ನಿಮ್ಗೆ MCQ ನಲ್ಲಿ ಡೈರೆಕ್ಟ್ ಆಗಿ ಕೇಳ್ತಾರೆ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಏನು ಮಾಡಬಾರ್ದು ಈ ಪಾಯಿಂಟ್ ತಲೆಯಲ್ಲಿ ಇರ್ಬೇಕು if the end support is roller simple knife edge or hinge the final moment is 0 always why that's very simple it will allow rotation that's why that is 0 why fixed we are getting moment it will resist the rotation that's why we are getting ನಿಮ್ ಮತ್ತೆ ಅಲ್ಲಿಗೆ ತಗೊಂಡೋಯ್ತು ಸ್ಟ್ಯಾಟಿಕ್ ಇಂಡಿಟರ್ಮಿನೆನ್ಸಿ ಕೈನೆಮ್ಯಾಟಿಕ್ ಇಂಡಿಟರ್ಮಿನೆನ್ಸಿಗೆ so any doubts in this next the final step bending moment diagram we will plot bending moment diagram and we will end the session okay now this is clockwise or anti-clockwise AB positive clockwise BA positive clockwise anti-clockwise and this is 0 right if you take this MAB you got clockwise MBA is also you got clockwise MBC you got anti-clockwise right and this is 0 and this is 0 see please keep in your mind that if I am representing like this clockwise or anti-clockwise the arrowhead is compression the arrowhead indicates compression and other end is tension and other end is tension please keep in your mind so here this is tension zone here this is tension zone here this is tension zone okay always when you are getting this whatever the final moment plot BMD of final moment not free BMD final moment on tension side whatever it may be in frame or beam both are same thing what is the MAB value you are getting around 2.5 2.7 all are same 2.52 2.7 and 0. You just join by a straight line because this is tension. See,
Yes, sir.
here we got tension, right? Clockwise. Here we got positive value or negative value, this one. Positive.
Positive, sir.
Okay. So here you have to plot here. Here. Then 0. Zero. Don't show it's a negative still. Okay. So this is final moment BMD. With addition to this, you are having UDL and point load. For this, you are having for UDL, it is parabolic. What is the value? WL square by 8. For point load at exactly center, this is triangle, WL by 4. Now you can impose this diagram in a single set like this. This value is WL by 4 and this value is WL square by 8. If you want, you can hatch this portion. It's a common portion. So this is superimposed diagram. This is net BMD. This is also called net BMD. You can expect a question like, if you are imposing free BMD and final moment, the BMD is called net BMD. It's a summation, net BMD. This is separate. This is free BMD. This is free BMD. This is free BMD. This is free BMD. Now you can expect a question like, if they are giving one beam like this, they are giving certain point load like this. They are not giving value because they are asking, they are bothering about only shapes. Now guess what is the free BMD? This is the shape. This is the shape. Which one is right? Which is the free BMD?
A, sir.
Or above case?
A, sir.
A. Others? Which one is correct?
D.
Which one is?
It's option A.
A. Why A? Free BMD. I'm asking free BMD. What is free BMD? See, you are having triangle, right? So for triangle, for point load, what is for point load? For point load, the free BMD is triangle. This is A point and this is B point. A to B, you are having point load, right? A to B, you are having point load. Next, B to C. B to C, what you are having? B to C? UDL. Therefore, what is the free BMD? For UDL, parabola. Which one is correct? Which diagram is correct? See,
D.
this is triangle, parabola. So the correct answer is D. The correct answer is D. Any doubts? Any doubts? Okay. So we will discuss a few more questions when we are coming to MCQ. Nothing to worry about this thing. Okay. Thank you. Now we are coming to the conclusion that we solved one problem fully, and also we discussed regarding so many things in today's class. FEM, what is FEM, what is rotations, what is stiffness, and all the things we discussed. Very, very important concepts. So I hope this class you have got so many things, because in yesterday I just explained, I have briefed what is meant by static and kinematic indeterminacy. But in this class we have taken few more problems, and also we discussed what are the relevant equations, and also we discussed what is the difference between degree of freedom as well as kinematic indeterminacy and all. So I hope you have got more knowledge with respect to analysis of indeterminate structures part. Tomorrow we will discuss MCQ related to slope deflection method, as well as we go on in second session, that is moment distribution method. So don't miss the class. You are getting definite questions in this particular part. Okay. Thank you, Pa. Thank you.
Thank you, sir.
Sir,
Yes, Helma.
sir, may I know when will you be taking influence line diagram, sir?
After MD method, Saturday, Sunday.
Okay, sir. Yes, sir. That's what I wanted to know. Okay, sir.
Yes, of course. I'm going as per your syllabi.
Okay, sir. No, sir. Like, I just wanted to know, like, after which topic will that be coming? Yes, sir.
Definitely. After this, you are having influence lines. That's a very, very important thing. Next,
Yes, sir.
finally, arches.
Okay, sir. Sure, sir. Thank you, sir.
I will complete whatever they have assigned to me within whatever the given time. It's enough. But you must practice. ನೀವು practice ಮಾಡಬೇಕು, ಗೊತ್ತಾಗಲಿಲ್ಲ ಅಂದ್ರೆ ನನಗೆ ಕೇಳಬೇಕು.
Yes, sir.
Okay, sir.
Okay? Okay.
Yes, sir.
Thank you. Thank you all. Good night.
Thank you, sir.
Thank you, sir. Good night.
Thank you. Thank you.
Thank you, Dr.